Unit 4 being lubrication systems. And you'll see it'll cover everything from oil itself, which will go along with some of your discussions, like um, a Valvoline video talking about the different types of oil and everything. And then going as far as diagnosing low oil pressure concerns. So the entire lubrication system be included. So just first, some basics. We have our engines, they need lubrication just to keep from wearing out quickly, if not pretty close to instantly. If you want to find out the hard way, go ahead and do an oil change, but don't put the oil back in and deliver the car to the customer and see how long it takes to come back. It's absolutely critical to the life of the engine. And that includes anything with an engine. So we focus really on cars and trucks, but that would be lawnmowers, weed whackers, big diesel cargo ships, like really anything with an engine. This everything you're going to learn is going to apply. And then the oil itself, it comes out of the oil refinery. So they pull the oil out of the ground, but the oil we put in the car is not really the same. We do a lot of refining. We do a lot of like what you can see here. We're going to remove a lot of impurities. And then we put a lot of additives in the oil. So some people would go as far to say as like, a lot of the base oils are the same. So let's say it was Pennsylvania crude oil. They're pulling it out of the ground the same as anybody else. If it's Quaker State or Pennzoil, they're both pulling very similar oil out of the ground. So what makes one better? What makes the other one better? It has more to do with the refining process and really more to do with the additives that they put in. So the oil itself wouldn't really do the job we need it to do. So we're doing all sorts of treatment, and that's something we'll cover a little bit more. And then just figure every moving part needs oil, but especially in the engine, every moving part is definitely going to need oil because the engine moves so much. And then everything included from the oil, the pump, the oil pan, the oil passages, that's all lubrication system. So that's all included here. So like if you look on this picture, they're actually showing crude oil, which was just pulled straight from the ground. They haven't refined it yet. So it's kind of interesting. That's what they're going to be doing in the lab. It starts off dark. So if you look at this, you think that's used engine oil, but that's not used engine oil. That's actually oil that's just raw pumped. So they're drilling massively deep wells, thousands of feet, and literally just pumping it. And a lot of times they're pulling it out of like tar sands. So the oil they're pulling, they're kind of extracting the oil from sand and sediment. So oil with sand mixed in is not going to be good, right? So they're doing tons of stuff to get it ready for what we need. It could even be thick. If they, in the refining process, they will make tar, like tar to put into asphalt. Asphalt is petroleum based. They'll pull that out, they'll separate it, and then other parts of the oil that they extract will actually become thin, like gasoline, diesel, jet fuel. It can even be used to make propane or like natural gas. That's all being extracted or refined from this crude oil. So when it's non-refined, it's crude, right? It's kind of like a person. If a person is crude, that means they're like, hey, you haven't really been, shown how to talk, shown how to act, shown you haven't been refined. So when someone's refined, they're kind of like dialed in. Same with oil, right? And we use this oil for all sorts of stuff in transportation generally. Okay, and so you can see what they mean here is like distilled. So that means they run it through a process and they extract it, or maybe more accurately, they take other things out of the oil and then it leaves us with a good base oil stock. Once we have a good base oil stock, that's kind of what I'm saying. Quaker State is from Pennsylvania. Pennzoil is Pennsylvania. They may actually have a very similar if to the same, maybe even identical base stock. Then they're going to put varying amount of additives to make it what they want. And so we'll get a little more into some of that stuff in the discussions in detail. But like, for example, one thing I've always told all the classes is I use Walmart Super Tech oil. And people kind of laugh and they're like, that stuff is junk. But it's kind of interesting. They may sell it as a Walmart brand, but if you think about it, the base stock is the base stock. They're pulling the oil out, they're refining it to a base stock. The big question is who's putting the better additive package in there? And I did some of my own independent research, which was based off someone else's independent research. So hopefully they're honest about it. But Walmart SuperTech oil has a pretty good reputation for additives. So there was, back in the day where we're at, there's a lot of business here. So there's a million oil change places. But if you were in rural United States somewhere, more like where near I grew up, to be honest, Walmart is like a big destination. You're in a small town. If you want to go to a place where you can buy groceries, you can buy things that you need for your house, you can buy tires, and you can also get your oil changed. Come up with a place you can do all that. And if it's not Walmart, I'll be shocked. So Walmart was like a big deal. So while here, not that many people get their oil change at Walmart because there's just a million places to get the oil changed. A lot of them were doing it at Walmart where I came from. So people would go there. They knew that Walmart was using their own kind of like house brand, this Super Tech junk. And if their engine had a problem, they were going after Walmart saying, Walmart uses cheap Super Tech oil. I've always had good luck with Castrol GTX. That's kind of like what my dad told me. Castrol GTX is the best. Why is it the best? I don't know. I asked him why it's the best, and he just say, "Well, I've never had a problem with this." And I thought, "Well, have you had a problem with other oils?" And basically, it was no. So he was essentially buying it because it had a cool name and the container was pretty cool. So people would go in saying, "Hey, you should use Castrol," and Walmart was like, "No, we use our own house brand oil to save money to keep the cost down." And they were blaming Walmart SuperTech for their engine failure. And Walmart was getting a lot of these, and they were, from what the story went, they were pretty frustrated in taking the blame and trying to have to clear their name. So they went to their supplier and said, "Hey, make SuperTech as good or better than everybody else. Put whatever additives it needs. Put anything to make it in line with the best." Now, that doesn't necessarily mean their conventional SuperTech is going to be as good or better than a high line synthetic oil. But as for conventional to conventional, SuperTech should be right near the top, but cheap. So after reading all that, I ran the Super Tech, and in the previous unit 3, when I did the um, Hummer engine rebuild, that thing had many, many, many years of Walmart Super Tech run through it. And actually, if you look at it, those bearings didn't really have a lot of wear. So when we're talking oil, we're talking about reducing lubrication. We're talking about reducing friction through lubrication. So the better the oil is, the less friction there will be. Mostly how we measure that in an engine is the bearings. So I took those bearings out, and those bearings really didn't have much wear. The engine still made good oil pressure. I'd say the Super Tech was good. There's only one thing I wasn't in love with, and I'm not sure that this will help it, but it was dark. It was very dark, and I related that mostly to, my truck has a lot of problems with running hot. Um, she's right here. It's got a tiny little radiator opening. So like there's a small grill. I've got this big bumper on here with this winch. It doesn't really get a lot of airflow. That's something we'll cover in cooling systems. But generally, my engine runs too hot. I'm commonly seeing 220 if it's warm outside. I even right now, if I were to drive it and it were to be over 100 degrees outside and I were to pull a trailer, I'd see 240 on the scan tool. So it's not full blown overheating with steam, but it's running way too hot. And that means If the coolant's that hot, that means the oil's that hot. So the darkness in that oil may be totally related to the engine just being too hot. But after the rebuild, I said, you know what? I'm going to change over to Mobile One. Mobile One's twice the price. Mobile One synthetic, top of the line according to the manufacturer. So I'm going to run that, and I might do my own independent assessment if I ever have to take that engine back apart. Because the only little beef I had with the Super Tech was it was dark in there.
Have you heard of liquid moly oil?
I've heard of all sorts of Molly oil. They put molybdenum and all sorts of stuff. So tell me what you know about that.
Um, well, I have a friend who's using liquid moly, and he's saying that it's lasting longer than the other oil he was using, which is the Mobile One. And he
Hmm.
was basing that based off of how the oil looked after 3,000 miles compared to Mobile One. And it was like pretty much like it looked the same as like when he put it in 3,000 miles later as compared to Mobile One, where it was like all black and dark.
Okay, that's really good input. I want to actually come back to that in a little bit because the next slide tells you the purpose of the oil. And this is in no particular order, but first thing it lubricates, right, which just means to lower friction. So so to put a quality of oil to the test, it'd be hard to say this one lubricates better and this one lubricates worse, right? Because you'd have to really do that in a lab. They'd probably have to take like a block of steel that weighs a certain amount, put it on another block of steel, put a layer of oil in there, and then measure how much pressure it takes to slide the block of steel. So if the homie's whipping the dipstick out and looking at the oil like this oil is better, that doesn't evaluate whether it lubricates better. You know what I'm saying? Another one is cushions. So I'd like to spend a moment on cushions. Right here, this thin layer of oil is the lubrication, and that's why it lubricates. Those two pieces of metal, they have a coefficient of friction that's not bad, but not that good. Oil is going to be like a little layer of particles separating the two pieces of metal. That is the lubrication. Those two pieces of metal should never touch. And that's very true, especially for like a main bearing. But for a rod bearing, remember the rod bearing is getting punched in the face by the power stroke all the time. As soon as that spark plug ignites, that flame front moves down, it puts a lot of pressure. So that connecting rod is trying to push down and have that bearing surface touch the crankshaft at the rod journal. The oil itself should cushion that. That's part of the reason we need not only just some oil in there, we need pressurized oil to really, let's say 20, 30, 40 psi to be able to withstand those power pulses to prevent that bearing from contacting the crankshaft. So the ability of the oil to cushion, that's a hard thing to measure. I'm not really even sure how they measure that, to be honest. I know a little about the friction. And then another one is cooling. So the oil itself, a lot of times we'll have an oil cooler, something we cover in just a few minutes. If the oil is sent to the right places, particularly with these piston cooling jets, it can actually cool the piston and reduce engine heat by 10 to 20%. Sometimes we rely on the lubrication system to cool the engine up to 20%. And so to say whether one oil can do that better than another oil, again, that's laboratory testing. And then I'm going to bump these out of order. Okay, we're going to stop with seals first. Seals doesn't mean it makes your seals seal like your crankshaft seal or your rear main seal. What it more means is when your piston goes up, the oil should be splashed onto the cylinder walls, and that oil should help your piston rings seal. So we're using that to basically keep our compression where it should be. So when we do some compression testing next week and the week after, we'll do a dry test and it'll be like maybe 160 psi. Then we'll put some oil in there and it'll bump it to 180. That's evidence that the oil is helping the piston rings seal. So that's another function, another one hard to measure. But I want to stop at this one cleans. So if you think about the job of the oil as like a cleaning agent, think of it like a degreaser. If you were to wash your dirty engine and spray degreaser on it, and then the water coming off of it and going down the drain is really dirty, that would kind of be like, oh, this stuff cleans really well, right? Because the dirt came off the engine and went into the drain. That would be an effective degreaser. But if you sprayed a degreaser and then you rinsed it and the water coming off your engine was still clean, where's that dirt? Where's that sediment? You tell me. Hmm? So I spray an engine with degreaser. You guys, I want you to answer me. I spray it with degreaser and then I rinse it, and the water coming off of the engine is still clean. Where's the dirt?
Wouldn't it collect at the bottom?
It should, but the thing is, it's not really removing it, right? So a good degreaser, you're going to spray it on the engine, and when you spray the water to rinse it, all that dirty water is like, okay, I see the dirt that I've taken off the engine, and it's in the water now, right? The dirt went into the degreaser and in the water. The purpose of a degreaser is actually to emulsify, which means it makes water and oil be able to mix, right? So the degreaser kind of breaks the oil down and makes it so the water can carry it away. That's a good cleaner. If an engine oil is a good cleaner, the engine oil itself should be dirty, because the dirt and the debris in your engine doesn't come from the oil, right? The oil that we put in there is clean. So the most of the color in oil, you've seen dark oil, that's mostly due to contaminants that came from the combustion process, and we're burning the gas. So like actually the gas puts the contaminants in the system. Your engine should be basically a sealed system, right? We shouldn't be having dirt getting in anywhere. If you have dirt getting in anywhere, you got a big problem. So how does it get dirty? It's not because the oil just burns up. It's actually because we spray gas in the cylinder, we burn the gas, and it leaves, impurities behind. And then the engine oil rinses the cylinder. And the engine oil, if it has good cleaning additives, should grab those imperfections and those debris and those whatever the impurities are, and it should grab it into the oil and it should carry it. And see, so if the oil's not a good cleaner, the oil just leaves it behind. Your oil still looks clean. So like this oil's great, but those impurities are building up, somewhere. And I'm not really meaning to poke fun at the homie, but what I find, a lot of people will quantify the oil's quality based on like, well, I pulled the dipstick out and it looks clean, or I pulled the dipstick out and still feels slippery. Like those are really bad evaluations. That's like saying I went and I drove a car and the car felt good, so I know it's going to last a long time. It's like it's not really a measurement of how well the oil's doing its job over hundreds of thousands of miles. So if you really wanted to know, um, I've actually got a test kit around here from Blackstone Labs. What you would do, let's say you put the mobile one in, you run it for a number, 5,000, 7,500, 10,000 miles if you want. And then you could take that oil and send it into the lab, and they'll give you analysis, the friction level, how many deposits and impurities were picked up by the oil, all these details about the oil, and including if there's bearing material being found in the oil, because as the oil breaks down, it loses lubrication properties. It may start to actually contact the bearings. The crank may hit the bearings, like especially on those rod journals, and it might start to wear the bearing away, and the bearing material should now be suspended in the oil, and the lab can pick that up. Then if you were to run the liquid moly and they were to get it back and be like, oh yeah, the lubrication properties are amazing, there's no bearing material in here and all that stuff, then I think the homie should have a really good audience to say like, hey, I've got some evidence. But to pop the dipstick out and be like, yeah, this one looks cleaner, that's like a elementary level understanding of the lubrication system. I would completely disregard, but he probably feels better spending twice the money on like a really fancy bottle. No offense intended, so don't take it that way. Now, I got quite a few questions. So I saw Roberto first. Roberto, you still got a question?
Yeah, I was just gonna ask, isn't that why people put catch cans on their car? Doesn't it collect dirty oil or something like that?
No, slightly different point with the catch can, and the catch can is actually more part of the PCV system than the lubrication system. I'll give you like the tiniest explanation, then I want to hold that for later. PCV stands for positive crankcase ventilation. When we're pumping those cylinders up and down, we can tend to build a pressure in the crankcase, which can tend to push the oil out somewhere. Push the oil out through seals, push the oil out through the intake, push the oil out into the air filter, etc. The purpose of a catch can is to basically let the air vent out of the crankcase and then have a tube like a can, and the oil should fall out of the airstream and into a catch can and then continue clean, which if it vents to atmosphere, that fails smog in California. But if the catch can ties back into the existing PCV system and it's a sealed, closed loop, if you will, then actually a catch can be carb approved, smog legal, could be good. A catch can's a good thing, but it has nothing to do with dirty oil. It has all to do with keeping the crankcase pressure low while not necessarily letting the oil go up through a PCV system into the intake or similar. The catch can just captures it better. Okay, now single overhead cam 2.5i. You're up. Okay, if you don't know that that's you, it's because you signed in as SOHC underscore 2.5i. I'm gonna ask to unmute you. I'll tell you what.
Yeah, they said their mic's not working in the chat.
Oh, somebody read what the chat says.
My mic isn't working. 1 sec. That's my phone's name.
Your phone's name is an engine's name. Okay.
Allegedly, it is for them.
Colin.
Yes. Oh my God.
Sounded Subaru-ish. I kind of thought. Okay, Colin, you put your question in the chat, and then we'll come back to it, and maybe somebody could read it because I can't see the chat at the same time as the presentation. Okay. So again, lubrication involves reducing friction, but also protecting against corrosion, preventing metal-metal contact. So that's all the stuff we kind of summarized right there. And then, like generally, friction can be good with brakes. That's why we don't oil our brake pads. Friction would be bad for engines. We want 0 to no friction from an engine if possible. If you had an engine that had no friction, it would last forever. You understand? There would be no need to replace it. So the less friction we have, the more the engine will last. And that's not focused on the pistons and the rings going up and down the cylinder. We're more looking at like the crankshaft and the bearings and the rotating parts. We want to be as close to no friction as possible. And so that's generally what it's talking about. It collects the heat and it should return to either the sump to cool or an oil cooler, which we'll cover. We put all those additives in there. And again, it helps to seal the piston rings. So if we were to look at an oil of choice, these are the purposes. The viscosity we've talked about a bit, that actually comes up on the next slide. So again, that's how easily does it pour in a way, like how thick is it, how thin is it? And this breaks some of that down. And I'll give you like a bit of a preview. The 0W means winter. So that's basically the viscosity at 0 degrees. So at 0 degrees, this oil is going to act like a 0 weight, which is water actually. So it's going to be similar to water, but at higher temperature, 212, which happens to be boiling, it's going to act like a 20 weight. So this is what we call a multi-grade oil. In fact, we call right out, we want a multi-grade engine oil. It's ILSAC GF4 starting in 2005. And we've actually gone up since then. So as long as you see it's ILSAC is going to be listed, it may be listed by API. This is just Toyota saying, this is the engine oil that we approve. That's not to say you need to use Toyota brand. It needs to meet the API certification. It needs to meet American Petroleum. API is American Petroleum Institute. And then we'll actually come back to ILSAC, okay, International Lubricant Standardization and Approval Committee. So there's basically 2 different ways that oil needs to be certified, and then it's good. It doesn't necessarily need to be one brand. or another brand. Okay. But if you look at the 0 and the 20, this confuses people. 0 is thin. Now, typically, if you were to take, let's say, ice cream, and the ice cream were to be cold, it's going to be thick. It's going to actually be solid, right? What happens if you warm ice cream up? Does it get more solid or does it get more like runny?
It gets runnier.
Definitely. Okay. So what about um water? If it's cold, it's ice, right? And if it's warm, it's water. What about grease? If you go to put grease on a vehicle and it's really cold, the grease can be kind of thick, but as it warms up, it kind of thins out. In fact, that's one of the reasons we use disc brake grease specifically, because a regular type of grease can get hot enough in the wheel bearing, it'll actually run out onto the brake pads and stuff, right? So in nature, things get more fluid when they get warmer. Okay, that's just how it works. There's a problem with that. When it's cold, it might be too thick. Makes sense? So if we run a 20 when it's cold, it might be like, if it's really cold out, it might be like a sludge. It might not do a good job of lubricating. So then we say, okay, well, then we'll run a 0. You run a 0 and the cold starts like, oh, cool, this oil is way better for me. But then it gets hot. If it's really hot out, your 0 weight is going to be too thin and it's not going to build good oil pressure. The thicker the oil, the higher the oil pressure, right? So the thin oil is going to be like, on hot temperatures, I just can't keep oil pressure. Now you have contact to that crankshaft and bearing, you're killing your engine. So these multi-grade oils are amazing because it can be like a 0 weight when it's cold, but it can be like a 20 weight when it's warm, or any number for that matter. And some of the Europeans are kind of frustrating. They'll run like a 0W50 and you're like, what? At 0 degrees, it'll function as a 0. And at 212, it'll function as a 50. That oil's got a massive range of how thin it can get and how thick it can stay, right? It costs more money to do that. We have to add polymers and do additives to make the oil function that way. It doesn't want to function that way. Oil as you just make it is either a 0 or a 20 or a 40. It's just 40. So if you remember Fast and Furious, they're, like, where are the engines, Ted? Where are the engines? And Ted's the parts guy, and he's like, I'm not telling you, man. And then they pretty much like throw him on his back, and then you know what he asked for? They're gonna put something oil in his mouth. They're like, what oil? He's like, 40 weight, 50 weight. And it was like 40 weight or 50 weight. Who the heck runs that anymore? Nobody does. That was just your single grade oil. It's just 40 or 50. They were different oils. It's like pull 40 out, pull 50 out, and then pump them. And then Ted's like, "Oh, they're in the warehouse." Right. So that was kind of a fun scene for me to point out. Back in the day, you had a choice. You could get a 0 weight, which they never sold. You can get a 20 weight, you can get a 30 weight, whatever. When you see SAE 30, that doesn't stand for straight 30. It stands SAE's Society of Automotive Engineers. It's just not a multi-grade oil. Those are cheaper oils. We still may use those in like a lawnmower. Lawnmowers don't get started when it's 0 degrees outside. You can't mow lawn when it's snowed. Okay, so we don't need a big temperature range for some small engines. They may call for SAE 30. And if you wanted to run a race car and you only drove it while it was warm out, you could technically probably run an SAE 40 or 30 or 20 or whatever, but you'd have to refer to the manual, and the manual would give you a range. If this temperature to this temperature, you can run this weight oil. So you do your own research. I wouldn't ask the people on the forum. I do your own individual research to see, but to be honest, there's probably no reason. You run the multi-grade oil, and that oil will have you covered in the cold. It'll have you covered in the warm. Those Europeans would run in 0W50. That's good for Iceland or Russia in the cold, but also good for Africa in the desert, right? So they have a big stretch there, but that's also the reason some of those oils are really expensive. Okay, now somebody go ahead and read Colin's stuff in the chat.
I got a different question, and now my mic works.
Shoot it.
So I remember there was this one customer who who insisted that he got 5W30 in his 2020 4Runner because all his friends from Puerto Rico run it.
Yeah.
What would you say would be the reason for that, or why shouldn't he do that?
Okay. These are good questions. It makes it so I think to really explain this, I gotta call Audible here, but that's fine. I'm gonna pull something up that's a little outside of the curriculum, but I realize it'll actually be pretty good. We're gonna do an oil temperature specification chart, and I want to pull this up for you. I've actually probably got one in my I would have to pull one of my service manual hard copies out. It may be very hard to find this on TIS for the record, because this is just not really something we do anymore.
Oh,
Just wait for me.
okay.
Then in new tab. Okay, about to pull this over. All right, so I want to break this down. So, first off, a lot of automotive questions and concerns come from just straight misinformation. In fact, a lot of problems in general throughout society come from misinformation. So, generally, you guys are gonna want to remember how to determine whether you listen to a person, you don't listen to a person, right? So my buddies run it in Puerto Rico. Right there's a few red flags. My first question would be, if I run 5W30, which is not what Toyota calls for, and the engine fails, are the buddies in Puerto Rico going to show up and fix the engine? And the answer is, it ain't going to happen. So the first indication is whoever is going to put their money where their mouth is and warranty the vehicle has the ultimate say. Make sense? So first off, I would have dismissed that. But see, I probably could have explained it better, and that's not because my intelligence level's higher. It's probably lower than a good portion of you. It's because I've spent a long time pursuing the facts, right? So when somebody asks me a question, I sometimes write it down, but a lot of times I just log it in my mind and then I go dig to find the answer. So this is something that's not covered in service info, but I'm going to break it down for you. If this was from that 4Runner service manual, which I doubt you'll find, okay? They used to be more common though. If this was from the 4Runner service manual, and let's just say the uppers are Fahrenheit and the lowers are Celsius. No, actually, I got that backwards. The uppers are Celsius and the lower Fahrenheit. Let's go with the Fahrenheit, because I don't know those Celsius numbers here in America, and we speak American, okay? It's better like a foot and an inch and stuff like that. So let's say you're in California. What do you think a realistic temperature range is where you guys live from the coldest day to the warmest day? How low can it go?
Probably like 60.
Yeah, sounds right.
That's for the high. You going to start the car at noon, or are you going to start the car at 5 a.m.?
5 a.m. I'd say the lowest would be, yeah, I'd say 50. It doesn't get that cold here.
Okay, so if it's 50 as the lowest of the low, then you need to at least go down to this number, which means 40's out of the question. 30 could work, 20 could work, 15, 40, 1040, 520. But look, 0W won't work. But typically, remember, we're using these multigrades. So if you look at zero weight is too thin to be able to go down to 50. So zero's out. So if somebody says put zero in, you're like, no, zero is in fact, actually, zero would be fine, but zero doesn't go warm enough. So I actually did that wrong. Let me back up right here. If it goes down to 50, 40 weight's out. 30 weight's just barely in. So on the low end, we have to have the coverage of the oil go below the lowest. Now, to make this a little more interesting, I'm going to tell you some of the things I've seen on the way in, like in another couple months when it's December, or at least end of November, when we're on our way into Cyprus at 640, 630, look around. You may see frost on some of those buildings occasionally, not every year. If you see frost on the building, you're not at 50, you're at 32. All right, so let's just say the customer lives somewhere where it gets a little colder. Like for me, this morning was 47. In another couple months, I'll easily be hitting below that 32 number. That means for me, the 30 won't work. For you, the 30 may work, but for me, the 30 won't work. Let's just say the customer in the 4Runner says, oh yeah, I might go to Big Bear. Okay, cool. Well, Big Bear, you might actually get to maybe not, but maybe the 14 number. If you're going to see 14 for the low, the 20's way out, the 20W50's out, your 1540 would be like maybe just on the line. But let's say it got to a 13, now your 1540's out. So you really can't run 1540 if there's any chance of going to Big Bear, right? Now let's throw it on the other end. How hot does it get where you guys live? You gotta
104.
Yeah, you got to pick one of these. It goes above 86, I know. So it might not typically get to 104. It might be like extremely rare. But the other problem is this person only going to drive it behind the beautiful curtain of Orange County? Probably not. They're probably going to be like, oh, yeah, I got invited to Palm Springs. So if they go to Palm Springs, actually the number is going to be 122, right? But let's go with 104. If it's 104, the 40 weight's chilling. The 30 weight is like, you're maxed out. You better hope it doesn't go to 105 because your 30 weight's no longer good. Your 20 weight doesn't reach up far enough to get to 104. You're already, that oil's already a no-go. So if you look at the 2050, you're like, hey, 2050 would go above that. 2050 would get me all the way where I'd be good in Palm Springs. 1540 actually would probably do a good job. Now look at 1030. 1030 is actually coming up a little bit short. 1030, they don't want to see over 104. Remember, this is an example. This is not for that 4Runner. I can't speak for that 4Runner because guess what? Toyota didn't publish this document, this image for the 4Runner. So whatever this is, this came off of, I think it was some sort of BMW site, right? So this would be specifically for that engine. But you'd look at it and say, if he wants to run 5W30 is not listed. Let's say he called to run 5W20 and you're like, okay, 5W20 is good for 68 degrees. It'd be like, you want to run 5W20? Take it someplace else and let them put it in there. I would never, as a Toyota dealership employee, I would never, ever put an oil that you knew was not meeting the spec in the vehicle. You know the saying, the customer's always right. You'll find when you get a customer who's asking for something that's going to damage the vehicle, if your foreman or somebody gets involved, they'll tell them straight up, no. They'll tell them, we won't do that. And if the customer says, I demand it, they'll say, we're going to put whatever it calls for, right? 0W20, 5W20 maybe. We're going to put that in there and we're going to charge you nothing and you can take it somewhere else. Don't come back. That's going to put the people in check a little bit. So what oil should you run? The oil cap is going to give you your general range. TIS is going to give you your general range. If the customer lives in Puerto Rico and the lowest temperature Puerto Rico ever sees is, let's say, they probably might not even get down to 50, but let's say 50. And the highest temperature they ever see is 86. You actually may run a different oil in Puerto Rico, but California's got some temperature swings. Most of the US has some big temperature swings, right? From winter to summer can be a big swing, and that oil's got to be in there from winter to summer because the oil change interval may be 10,000 miles. So everybody clear? I can't give you the answer of what oil to run or not to run. All I could do is tell you how to go source the information and give the information as a matter of fact. And then the liability is not really on us, right? So if I run 10W30 and there's a problem and the customer says, well, it's because they ran 10W30, I would say, well, I ran 10W30 because the manufacturer service information calls for 10W30. If you think that 10W30 is incorrect, I'm not the guy you want in court. You got to haul some dude from Japan who wrote the service manual, and it'll never get to that point. See what I'm saying? So you don't ever give advice based on what you think, what you feel, like what somebody said, what you're, even if you've run 10W30 on your 4Runner for your whole life, like that's only one vehicle. That's statistically a crappy sample size. Super clear? Okay. Now, it's a lot of questions. Go ahead, Colin.
Okay. So we tried to tell him that we shouldn't do anything besides the service manual or anything that besides what was recommended because it's different temperature from here, different environment from here to Puerto Rico, even though the Puerto Rican service manual tells you it should be that. We don't want to do that here because it's not safe. And I tried explaining that, but they ended up just bypassing that. I'm like, just do it, Colin. It
Okay.
seems to happen a lot at our dealership. We just end up doing what the customer wants, even if it's not safe, and I recommend not doing it.
Yeah, I mean, know your role for now. You're a peon.
Yeah.
No offense, but you guys are coming up, but when you're the lube tech and if your service manager or your foreman says to do it, you're going to do it, but you're going to know that you gave good advice. But that's what's very frustrating. You can have great advice and then somebody will just reject it and be like, yeah, but somebody else said to do it. I'm like, oh, okay. So I spent a good part of my life learning the facts and learning the truth and trying to give it to you. You just disregard it for something that someone else said. Okay. You know what I mean?
Yeah.
Let
Yeah.
it go. Let it go. But as for the fact goes, negative. Service manual.
Sounds good.
Mitchell, you got your question now.
Not really a question. It's not really a question, but more so, once we had a RAV4 come in that was sold in the Mexican market, I mean, it had a Toyota Tijuana plate on it, so
Yeah.
and yeah, the oil cap said 5W30, so the oil
Yeah.
cap said, yeah, so
And think about why. Mexico's south, right? So Mexico's warmer.
significantly so.
If it's warmer, you want a thicker oil, right? So in Mexico, they don't have places that are going to get below zero. That's just
Yeah.
not. So it makes sense, and you're exactly right. It has to do more with the climate. So back in the day, they used to give us these types of things, but now they just don't really give us those charts anymore. So essentially, as the dealership technician, I'm instructing you, follow what the service manual says. And if the service manual is a US based service manual and the car's in the US, I would not be doing what the global market service manual, whatever says, because that's not where the car is. Kind of makes sense. All right, cool. So now we'll jump in a little bit more because we're going to talk about more about the oil. So here's your viscosity. This high viscosity is going to low viscosity is going to so high meaning the higher number. The 5W30 is a thicker oil than the 0W20. So the high viscosity 5W30 is going to be slower pouring, and the low viscosity is going to be quicker. That's how they measure it. And that all has to do with how the oil is going to flow through the system. And I'd like to add something just a little ahead of time that I add a little bit later. If you run the incorrect oil, yes, it could cause damage, but the variable valve timing system, VVT, it really relies on the oil flow, the oil pressure, the oil volume. All the oil aspects affect how much the VVT advances and retards the timing. If you're running an oil that's too thick or too thin, not only might you cause engine damage, you might actually get a check engine light for a variable valve timing problem, like maybe even crankshaft, camshaft correlation, because it's not moving the VVT as expected, because this viscosity is calculated. This viscosity is expected to be in this range. So when they write up the parameters, they're going to say it should never go below this, it should never go above that, and they'll build in a little buffer, maybe a little error room. And that's dependent on the viscosity of the oil. So if you run outside of that, you may actually set DTCs, not because your VVT system is bad or the wires are cut or there's wear on the actuators or sprockets. It's like it relies on the oil. So an incorrect oil change could cause a check engine light, just for full clarification. Not only from theory, I've seen it actually on several occasions.
What if it's like specifying a certain grade of oil? Like, I forgot exactly what it was, but like it was like on the back of the bottle, and it was saying like use some grade oil. I need to check my oil cap.
Yeah,
It says the same
it's
thing.
going to be like this. It's going to say something like API service SM. The standard is API American Petroleum Institute. SM is the standard. Now, if it calls for SM and you have a higher standard, that's good. That's almost like, yeah, you exceed the standard. That's good. But if they're calling for SM and let's say you found some that it goes in alphabetical order, right? So HOJK, LMN. If you had SN, which is more current, by the way, SN is good for SM. but SL is not as good as SM because it goes LM. L is the old standard, M is the new. So if you have a car that calls for SM and you have SL oil, I don't know. That's kind of like, it's a little similar to .3, .4. If you have a car that calls for .4 and you put .3 in it, shame on you. But if you have a car that calls for .3 and you put .4 on it, that's cool. Just don't play around with 5, right? Because it's silicone based. It's a similar standard. So to be very honest, pretty much by the time they come out with a new one, like SN, right, is after SM. This one's a little old. All the part stores are just going to change over. Everybody's going to have SN, and then there might be some leftover SM, and that is where it could be a little bit sketchy. But if you get a brand new car, you're in a little bit of a weird spot. But by the time the car comes out, they probably already changed the oil standard over. Probably all the part stores already have the correct oil. If you go in, you're going to say, I want this oil. I want O'Reilly's house brand oil. Trust me, it's going to be to the latest standard. Now, that's for the API. If your car calls for synthetic X, Y, and Z, that doesn't mean that every oil is going to meet that standard. So there's like API is common. The ILSAC is fairly common. Like a lot of times they'll have some sort of a starburst or something similar. If it's GM, they're going to call for like Dexos 1 or Dexos 2. So yes, we need to make sure that the oil is meeting those standards, but they'll never call for like run this brand or that brand. At best, they'll call for run this level of certification. As long as you can find an oil that meets that certification, you're good. You should be. You're not going to void your warranty, in other words. So it's a good thing. You guys can look that up. Go a little bit more in detail on the oil on the video. Okay, we're going to focus more on the lubrication system now. So conventional, synthetic, and synthetic blend. Conventional, it's processed from petroleum and uses additives, right? So it's basically the oil refined and distilled to a clean base stock, and then we put additives in, but it's still the oil from the ground. Okay, that's kind of the point. Here's literally pulling oil out of the ground from those underwater wells. They pull a bunch of stuff out, like they pull the wax out. They'll actually use the wax for candles. They break it down. They could break it down into basically what's considered mineral oil and then combine the additives. And then let's say you had synthetic. So type 3 is not exactly a true synthetic. Like they do more refining, but it's a bit different. Type 4 is it never came out of the ground. They made it in a lab. They formed it in a lab. But both of them are more costly to manufacture. So if you want a synthetic oil, cool. It's going to be more money. It just is. It costs more money. You don't get to pump it out of the ground. You have to actually manufacture it. It takes more time. And then advantages. Okay, so we could go into a ton of detail, but we'll keep it simple. Better protection against engine wear, so that's friction. Can operate at higher temperatures. So everything we saw on that previous page, I don't know if that was for synthetic or conventional, on that chart. I'm not sure. That was for whatever that vehicle called for. It's probably conventional, right? They have better low temperature viscosity. So when you want to actually be able to run to a lower temperature, you could change over to a synthetic. Fewer wax impurities. So wax impurities, do this word here, coagulate. If you guys ever cut yourself and your blood leaks out, what happens?
Put a Band-Aid on it.
Okay, you can put a Peppa Pig and George Band-Aid. But what happens when you take the Band-Aid off, you're no longer bleeding. How come? Starts with an S. What's it get on there? It grows something.
Scab.
Exactly. A scab is your coagulation from your blood. Your bodies are pretty amazing. I don't mean that to be a compliment, but I'm just saying your body is amazing. If you cut and it's leaking, it self-seals. So it's leaking blood, and the blood has a reaction with oxygen, and it initiates this coagulation. So your liquid blood is like, oh, coagulate. That means it gets crusty and scabs up. Okay, so coagulation is something that can happen in oil. So if you had wax in there and it coagulates, that'd mean it could end up with like little scabs, like little chunks, little hard parts. That'd be a problem. So that's why it needs a lot of refining. And synthetic will have fewer of these impurities. We don't want oil to coagulate, by the way. The only time you're going to have oil that coagulates is if you have put a stop leak in there, and the stop leak is going to look for the leak and instead clog up your oil pump or something. So we don't, that's ridiculous. Don't do that. That's not what we do as technicians. That's what like the common person does when they're hoping for a miracle. They're like, this next pitch is gonna be a home run. I'm gonna knock it out of the park. I'm gonna put this stop leak in there and it's gonna stop my leak and save me my money. Okay, but it's also chemically more stable. Some people would say the thinner oil tends to find the leak, and I don't know about all that, but there's some reputations about synthetic. And another thing I'd like to clarify here is, big question is, if you ran conventional, you can't change over to synthetic, okay? And that is not exactly true, but I'd like to clarify somewhat. If let's say you're running a conventional oil the entire life of the vehicle, the oil, let's assume, it's not necessarily true, by the way, let's assume that oil has less cleaning detergents, cleaning agents in there. That means it's not going to keep the engine as clean, right? And those imperfections and those debris are going to be in the engine. So basically what I'm telling you is the inside of the engine is going to be kind of dirty. Now, if you take that conventional that's been in there every 5,000 miles for 100,000 miles, and you put a synthetic in there, and the synthetic has a lot of cleaning agents, the cleaning agents are going to clean it a lot, right? So the oil flowing through your system is going to look like what? I think, how's it going to look if it's picking up all the imperfections as it flows through the system?
Dark.
Exactly, dark, dirty. It could have too much debris in it. All of a sudden, you might have more debris flowing in your oil than you ever used to. And that's where some of these, whether true or not, horror stories would come from. Like, yeah, I went with synthetic and the engine seized up or something. I went with synthetic and all of a sudden I lost oil pressure because all this debris was on my pickup tube and my sump. So to say that you can't go from conventional synthetic is sort of like, it's not exactly true, but if it was a low quality conventional that had very little cleaning agents and detergents, and then all of a sudden you put in a really high additive package synthetic, the oil will get dirty fast. And that could cause some issues because you're literally carrying debris through the system, and then the bearings could be, contacted by the debris and actually score it up, right? So there's some truth to it. It's just not to say the statement, you can't go from conventional to synthetic. You can't do that. Well, not exactly true. Especially, let's consider you had a vehicle and it had 10,000 miles on it. You've done one oil change. And then let's say at 20, you wanted to change to synthetic. There's not going to be enough deposits and buildup in that engine to cause an issue. You can easily go from conventional synthetic in that case with no issue. And the other thing is, even the conventional oils now have so many additives. They have so much good stuff in them. You're probably not going to have a filthy, dirty engine. So I still wouldn't, say it's a for sure thing. But if somebody asked me, I would take all these things into consideration and, maybe say, well, I don't know, the inside of your engine's pretty dirty. I'm not sure that I would go to a synthetic, because a synthetic is better, yes, but it's also better at picking up all your debris and running it all through the system. Maybe you're better kind of like leaving it alone and just riding it out, right? So that's something I wanted to make sure everybody's clear on. And part two is a conventional better than a synthetic? Or is a synthetic better than a conventional? On average, yes. But that doesn't mean you can't have a synthetic that they cheaped out on the additive package and a conventional where they went all out on the additive package and actually have the conventional outperform the synthetic. That does happen. So it really varies. The short answer in the dealership, guess what we're going to run? Whatever the manufacturer calls for. If the customer comes for a whole big education about oil and whatever, I hope that you have learned enough and will understand enough to be able to give it to them. But if a customer asks me all these questions, I would try to educate them, because that's partially what I like to do. But then at the end of the day, I'd say, you know what? I'm just not really that qualified to be able to tell you which oil you should run. I don't do the studies. I'm not the engineer. I haven't collected thousands of information data, you know, so I could tell you the theory and then you make your best educated guess is basically it. So I'll tell you what, why don't you just run what you're supposed to run in case anything goes wrong? You know, we can't say, oh, well, I found somebody who told me run this and that and the other thing, right? So that's just not our job. That's somebody else's job. If you happen to be in a forum with someone who works for the oil company and they literally engineer and manufacture lubrication systems or the oil itself and whatever, I'd be all ears. But that is like 0.001% of the population. So as soon as I'm on the internet and people are saying, oh yeah, this and this, and I just disregard. Everybody gets disregarded until somebody comes in and says, these are my qualifications. And if their qualifications are to that level, right? I work for mobile. I'm in charge of making mobile one. I do all these studies. I oversee all this data. Okay, now I'm listening. If it's like, well, I had a car with 250,000 miles. I'm not listening. That's just one car. Not good information, not good statistics. Cool. So continuing on synthetic. So this gets into some of the more finer points of the synthetic oil. Talks about PAO oil. They were coming up with synthetics as early as 1972. But actually, most of the synthetics are not actually full PAO. So a synthetic oil is not full lab made. It's going to be a little bit more in between. And to be very clear, I don't actually totally know how an oil is synthetic if it's not actually made in a lab, but you know, the actual full-fledged synthetic made in a lab PAO is pretty rare. That's gonna be an expensive oil for sure. Then let's say you buy oil that's a high mileage. Generally, the main purpose of a high mileage, they actually put some additives in there to make your seals swell up. Make your seals swell up like your rubber rear main and valve cover gaskets and stuff. It'll actually make them swell up, and that might potentially maybe help the leaking problem. It's not a coagulator though. It doesn't coagulate the oil. It just swells the seals, maybe. And then some of these higher mileage oils have extra things like polymers and stuff to lower the friction even further. So generally speaking, a high mileage oil is actually a better oil than just the regular. So I've actually got right here Mobil 1 5W30 and Mobil 1 5W30 high miles. And the only reason I got the high miles was because it was on sale. So I don't need high miles because my Hummer now has like 180 something thousand, but the engine's got like 5,000. So it's not high miles. The truck is, but the engine is not. And we got the Camaro, and I think the Camaro has 35,000 miles. I don't have anything with high miles that I need to change the oil in. My motorcycle got some high miles, though. That's the workhorse for me, right? I don't need mileage oil, but it was on sale, and the high mileage oil has these additional additives. I probably don't really need the seal swelling agent, but high miles is an improvement, I guess, at least marginally. So if you have a low mileage engine, to say you can't put high mileage oil in it, no, that's not really true. It's not necessary. I wouldn't charge the customer more money to put high mileage oil in there because you don't need extra polymers. You don't need seal swelling agent. But if it's on sale, it's fine. Okay, so that's why I got that. And then there's some heavy duty stuffs like, for example, Rotella T is a pretty well liked product, but this is SAE 1540. This is actually really made for diesel. That's not to say that someone may not run it, by the way, in a gasoline, but a lot of times the diesel oil is much more demanding. A diesel engine oil that's a compression ignition engine has a lot more heat, a lot more pressure. You know, from the factory, those things are running like 30 PSI of boosts. So trust me, they need to be holding up better. You could run, in some cases, a diesel oil in your engine, have the engine be happy. But here's the problem. You know, all engines burn a little bit of oil, and that oil ends up going through the exhaust, and that burnt up engine oil ends up going through your catalytic converter. I'm not so sure that your cat is going to be happy burning a little bit of Rotella T diesel engine oil, So that's the main reason I wouldn't really recommend it. They are a little different, gas to diesel, and so consider what you're buying. If you're running a diesel work truck and it calls for a 15W40 and you see the Rotella T, which is usually actually pretty well priced, then that could be good, but you don't really want to be running it in your gas BMW that gives you this viscosity range. Colin, I see your hand again. Did I miss you?
No, I think I forgot to lower it down.
Okay, very good. I forgot to lower it too, so we're both guilty. Now jump into additives. Extreme pressure additives, oxidation inhibitors. You guys know what that is. So extreme pressure, that has more to do with the rod pushing down on the rod bearing and crankshaft. Oxidation. Who knows what oxidation is? Oxidation with a iron is like rust. It has a reaction with oxygen. Oxygen breaks it down basically. Your paint on your clear coat on the roof of your car with too much sun, you'll see, will become like oxidized. The sun kind of breaks it down, and then the oxygen is exposed to, it's exposed to oxygen, and it basically flakes off. So oxidation is breakdown by oxygen. Corrosion is essentially stopping your engine from rusting inside. So if you were to have, unfortunately, you're going to have some traces of water in your crankcase. And if the oil doesn't have a good corrosion inhibitor, you can actually end up with rust in there. So we add these. Anti-foaming is an interesting one. When your crankshaft is spinning, your oil level should be below the crankshaft, okay? They shouldn't touch. But even still, like your oil's getting sucked up by the pump and churned through the gears and all that stuff. You don't want your oil being like frothy. Like if you make let's say you make yourself a smoothie and you run in the blender, it gets kind of foamy, kind of airy. That's bad. That's really bad because now your oil pump is sucking up air, little tiny air bubbles that are within the oil, right? So foam means air, and that would be a big problem. We want to make it so the oil foams as little as possible. We put additives in there for that. Detergents is like going to clean. Dispersants is going to make it so if it picks up like some sort of imperfection, it's going to disperse it through the oil. You don't want, if it picks up a bunch of sediment, you don't want a bunch of sediment together. You want it to disperse. Same with gas. Over time, there's a little bit of gasoline left over on your cylinder walls, and that gasoline ends up in your engine, in your oil. You don't want oil and gas. You want the oil to disperse the gas throughout to keep it so there's not really like, sections of gas. 4-point depressants, viscosity index improver, those both have to do with stabilizing the viscosity. So mainly to make it like a good multigrade that can go down to that, negative 22 degrees, but go up as high as 122 degrees. So we add a bunch of stuff in there. This all costs money, obviously. And then ultimately, again, deviating from the standards, that would be where you would be wrong. If you recommend the oil that the service manual comes from, you're functioning exactly how you were designed. You are not designed to be doing statistics and giving advice on which oil. You just don't know. Okay. Just be really honest. If you sit down and you're honest with yourself, you have no idea if the super moly, ultra mega, super duper gold plated oil is better. You don't. You just don't. You have no idea. Okay. Somebody else does. And that's why somebody else publishes which oil you should use. Cool. Then API gets in there. API is basically American Petroleum Institute, and they set the minimum performance standards for lubricants. So when API sets the minimum, all the oil manufacturers have to pull up to the bar. And then they have to send it into API, and API tests it. And if it passes, API gives them API certification. Then they can put the little starburst thing on their car. Kind of makes sense. So now if you look, oil rated S cannot be used in compression ignition. So wait a minute. S. Anybody think that they know what S stands for in this case? Because it doesn't give a lot of context here. S. Now compared to compression ignition engines, which also need the C. what ignites the air fuel mixture in our gasoline vehicles? What starts the fire?
Spark plug.
Exactly, spark. S is spark. That's it. S is a spark engine. C is a compression engine, that which basically means diesel. Cool. So they're different. That's what it's saying. This gets all into API. So SN, GF5, these are the standards. And by the way, a while back, they went to like energy conserving or resource conserving. So the government is involved in this. The government wants them to be remove a lot of the harmful things like zinc, for example, was really good for flat tappets coming across the cam. The zinc would really lubricate them well. Zinc not so good to be coming out the tailpipe. And so the government's involved in making them cleaner, making them, hopefully achieving better gas mileage and stuff. So there is a little bit of an input as far as making them better for the environment. It's not all on performance. So when I talked with an engine builder and tuner, I usually want to get other people's perspective, right? So this is not a manufacturer guy. He doesn't deal with the manufacturer at all. People bring him their cars and he builds them hot rod engines and does tunes. It's cool stuff you guys would like. But he's never really had the manufacturer type training. He's he's a builder, you know what I mean? He makes cool stuff. So I asked him, well, what oil would you recommend? He said, well, I used to run Royal Purple, but then, I would take these engines apart and they'd be all dark in there. And I would be looking to see if maybe I had like a PCV leak or like combustion pass blow by or something. And I don't run Royal Purple anymore because I just don't like the purple dye. So he kind of had a little beef with Royal Purple because of the dye. And that doesn't say that Royal Purple's bad. He just doesn't like it because of the dye. Then he said, well, right now, all I sell is AMSOIL. I'm an AMSOIL dealer. I run AMSOIL this and this and this and this. And I kind of asked him, like, so like on my Camaro, ZL1 says right on the cap, Mobile 1, 5W30. Why not run Mobile 1? Mobile 1 is like the industry standard. Mobile 1 is what GM is recommending, and GM made the vehicle and GM warranties the vehicle. And he's sort of like, oh, Mobile 1 is trash. And so I'm like, whoa, I've never heard that before. I was just like, what the, really? And not to say that I thought he was right, but like, maybe this guy knows something, So I listened to him. He said, Mobile 1, yeah, and I kind of asked him actually a more pointed question, like, if Mobile 1 is trash and GM provides the warranty for the engine, why is GM recommending Mobile 1? Because ultimately GM has to pay if Mobile 1 sucks. So I think that they would have done their research before they recommended that. And you're still like, no, it's because they're like kind of in bed with the government. The government tells them remove all the zinc, remove all these additives and stuff. And now you got Mobile 1 is just like the better for emissions oil. So I don't know. I had no way to really discern whether that was true or not, to be quite honest with you. But it was an interesting perspective to hear. If I'm going to shoot from the hip and make my determination, though, I'm probably not going to listen to an engine builder who started a little bit of a conspiracy theory right there. I'm going to probably go with the fact that the manufacturer will stand behind the product and offer me a new $14,000 engine if it fails, if I'm using the Mobile 1. Makes sense? So that's really my stance on it. But I'm telling you right now, I don't have the facts. I don't have the qualification to make the call, right? So this is what I'm saying with you guys. If you're following what the manufacturer calls for, that's exactly what I would do to keep yourself out of trouble. If you become more qualified and you can come back and teach me something, let me know. You got my information. Cool. So Ilsac jumps in and says, Ilsac, GF5. We might even have, I want to come back to this ACEA API, which is SN, SM, and SL. So it meets all of these. Remember, it goes L, M, N in the alphabet. So if you have a car that calls for SL, this meets it. If it calls for SM, it meets it. If you call for SN, it meets it. If it comes out with a new one, SO, it doesn't meet it, right? So it's almost like reverse compatible from anything SN and older. But if SO comes out, this oil would be not good enough anymore. It also meets Ford WSS standard, Ford WSS, another standard, GM Dexos, Honda Acura HT06, right? So this essentially what they're saying is like, hey, this oil is certified by this one and that one and that one and this one and this other one and that one. And like this oil is certified to like everybody's standard. That's actually part of the reason I keep a bunch of Mobile One. Mobile One, like if you look, that's what this is. This is a Mobile One oil. It's actually guaranteed to protect for up to 15,000. I'm not going to try it, by the way. I'm still changing my stuff early. Just that's kind of another side discussion. But the Mobile One oil, I believe you know, the oil itself won't break down. The additives are going to be excellent. The corrosion protection, the temperature, all that type of stuff, I'm sure is amazing. But 15,000 miles worth of fuel being sprayed in the cylinder and leaving deposits behind, and those deposits now being carried in the oil, that's going to tell me that oil's going to be dirty. And I see damage caused by dirt, not just damage caused by oil breakdown. So I'm changing the oil because when I change that dirty oil, I'm taking the dirt out of it. Makes sense. I'm taking the sediment out of the oil. However, would I recommend that to a customer? I probably wouldn't because it's just not my qualification. I'd say follow what your service manual says. I'd go with the service manual, not the back of the bottle saying 15K. The service manual wins out again. Okay, so a little plug for the Mobile One just because it meets all the certifications right there. So if I want to keep one oil on the shelf, I keep Mobile One, and that's going to be great for like everything I touch. Now, SAE, that again, that doesn't stand for straight 30 or straight 50. SAE 20, that's Society of Automotive Engineers. So they also set the standards. They work more on, looking at the engine and what the engine needs, and then making standards and making sure the oil meets those standards. So there's a lot of different agencies involved in this oil. Cool. And that's basically the summary. We'll go with SAE. A modern oil blend of oils that combine properties of oil and the desired outcome and all sorts of additives and everything. So like to meet the SN, they're going to need to have all sorts of additive package. So if it meets SN, don't think it's junk oil. Guess what? Walmart SuperTech meets SN. So if it meets the standard, it's not going to be trash. It's not to say it's going to be much above the standard. It might just barely meet the standard, where something else might exceed the standard. But I'm not really sure. We would have to send that out to a lab and have them test it. Okay, so like a cool YouTube thing to check out if you're interested, it's called Project Farm. That dude spends hours and days and weeks making a video to compare one oil versus the next oil, including having the lab results. They do some really cool stuff. And as far as I can tell, it seems legit. Cool. So they would have way more info than me because they would take that time to go through those tests. Okay. And then JASO is Japanese Oil Standards Implementation Panel. So it's basically like what API does, American Petroleum Institute, except in Japan. So if you really dig in the Toyota service manual, a lot of times it may call for JASO standard X, Y, and Z. So, but again, we're doing it kind of our way. So if it meets our stuff, you're going to be good. But if you look for it, cool. And then ACEA, remember I mentioned that one, European Automobile Manufacturer Association. So that's the other one. The different major continents seem to have their own. I didn't hear Puerto Rico's, Service Institute, Oil Institute. So maybe the boys in Puerto Rico that run the 5W30 know something that we don't know, or maybe they're falling under the US since it's kind of like a territory. I'm not sure. So that goes into a lot of the stuff. Now let's talk about the actual system. Okay. Taking a look at this is going to show you everything that is in the basic lubrication system. Let's start with where the oil starts. The oil's chilling right there in the sump. The oil's in the sump. Air is hitting the oil pan. It should be fairly cool by the time it gets in the sump. And then when we're ready for the oil is going to get sucked up through a strainer. And the strainer looks like, we'll show one more, but it looks like a screen. It's basically like a screen. It's hardly a filter. It's really not a filter, but it's a screen. and it's got to go through that screen. Small point right here. If you do an oil pan or a front timing cover and there's a whole bunch of FIPG and RTV and silicone and junk, and it ends up down in there and it clogs up that sump, you ain't getting no oil pressure. That engine's going to be damaged, if not destroyed. So just FYI, it goes up the sump through the screen, up this pickup tube, which, think of it, if we had a little crack or a break in that pickup tube, it would, and it was up here, it would actually suck air in there, and that could cause low oil pressure, by the way, just a thought. Or if it was the O-ring right here, just a thought. And then it goes into the pump, and the pump is drawing it, right? The pump is sucking it up the pickup tube. The pump has to be driven by something. And pretty much every time the pump is going to be driven by the crankshaft in one way or another, maybe through the timing cover, maybe through a sprocket, to a shaft that spins, to a pump, but something is ultimately taking the crankshaft's rotation and making it turn the oil pump. I want to pause there for a quick second because I want you to remember, if you turn the engine key on, click, click, or buttons on the smart key, your red oil light's on. If you're key on, engine off, your red oil light's on. Your red oil light is on because you don't have oil pressure. You don't have oil pressure because you don't get oil pressure till that engine is turning. Okay, so I want to make that point. A fuel pump's different. A fuel pump could be electrically driven in the tank. You could get fuel pressure. You can't get oil pressure till that sucker is at least cranking, and realistically, to get much oil pressure, it needs to be running. The oil pump is mechanically driven, period. And then the oil pump is going to send it up what we'll call these oil galleries. Oil galleries are basically like little tunnels, little tubes, if you will, through the engine. But most of the time they're like machined. It'd be like they run a bore through the block right here. And then they run a bore up here. And then they run a bore in the head. And right there, the head gasket has to seal the oil gallery. And that's one of the reasons that a head gasket could leak oil, because it's not sealing an oil gallery, right? So the oil galleries are all these passages, and the oil should be pressurized into all those passages, and then it should go everywhere it needs to go. It should go to the mains, and it sends it to the main journal. And then what's really interesting is, as the crankshaft is spinning, there's actually another hole. So we'll shoot it in the main journal, but then from there, it should jump over into this cross-drilled gallery, which goes from the main to the rod. It'll send oil through that passage to lubricate the number one rod bearing and journal surface, right? So we basically send it through the main, but then a hole in the crankshaft internally gets it over to the rod. Just remember that, okay? Because if you had a rod bearing that's burning up, you may actually have debris in that passage right there. Okay, so it's going to go to all these journals, and those are going to be constantly pressure fed with clean oil. How to get clean? Well, let me back up. When it comes to the oil pump, we pump it through the filter, and the filter should remove the debris. And then it goes to all these points. We send it up through the head gasket into the head, and we have it lubricate the camshaft. We might have it also do cooling piston cooling jets, which are oil, not coolant. We're gonna have it go everywhere we need to go. And then one way or another, the oil is going to go down some little drain. It's going to basically fall off the crankshaft. It's going to end up running its way down the oil pan and falling back into the sump. That's why we need enough oil. If you don't have enough oil and this thing goes low and the sump starts sucking up air, you just dropped oil pressure tremendously. And now we're not getting oil pressure to these bearings. And these bearings aren't getting pressurized oil, so we might actually get the contact, and now you have excessive wear. What I just described occurs on every startup. You jump in the car. If I jump in Bessie right here, I jump in Bessie and I go to crank Bessie up, rah, 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 rah. There's no oil pressure immediately. So for those first couple revolutions, it may actually be having, some metal to metal, or some bearing to crankshaft contact. It may leave a little bit of scores, right? So a good oil should leave a nice film, so it should minimize that. But sometimes a lot of our wear comes from actually the first startup while we don't have oil pressure. Once the oil pressure is built up, if it's clean, we really should have basically no wear. It's kind of interesting to think about. So that's one of the negatives of those cold starts. Some of the, like, let's say a municipal vehicle, like let's say it's a the post office, perfect example. You guys see when the post office delivers mail, they a lot of times have a policy where you need to shut the engine off every time you get out because they're worried about them forgetting that it's in drive. So this is just an additional safety measure. They say, yep, every time you stop, turn it off. Well, that engine, you pull up to the mailbox, they turn it off, they put some mail in the box, they start it up, they pull up to the next one, they turn it off, they put some mail in the box, they start it up. Those engines can be totally worn out. The starters also get fried, but the engines can actually have a lot more wear because there's just so many startups and startups and startups. It actually probably be better for the bearings to leave it running, but that's against their policy, and it's more important to keep the people safe than to keep the bearings fresh. They got a maintenance department. There's people working down there ready to pull that 4-cylinder iron Duke out and put some new bearings in it. They rebuild engines sometimes for the post office because they wear them out so much. Okay, Roberto, go ahead.
I was gonna ask, is that why the pistons make that noise or like the hitting noise in the beginning of when you first started up?
Slightly different. Good point. On first startup, you have no oil pressure. You may actually have the crankshaft kind of contacting the rod bearings right there. Because remember, as soon as you fire it up and it gets a spark and it gets combustion, that's pushing the piston down. You may get some contact. Sometimes you also can get some clatter noise because your timing chain is going to be tensioned by a timing chain tensioner that's hydraulically pumped up. So your timing chain tensioner might let go a little bit. Usually there's teeth, like ratcheting teeth, so it might not let go a lot, but a little bit. And then when you start up, it has no oil pressure. There might be a little timing chain slap, and then the oil pressure pushes the shoe out and tightens the timing chain right up. So those all might be related, especially after an oil change. So like if after an oil change you hear it more clattery, that's because you started up and it sucks up the oil from the sump and then it sends it to filter and your filter's empty. So it's got to fill the filter first before it builds oil pressure right here. That can bring up some clatter. Now I'd like to clarify though, if you have a piston and it's remember concentrically ground, which means it's not round and it's got a little bit of excessive piston to cylinder wall clearance, that's piston slap. Piston slap would last 20 to 30 seconds. That's different. 20 to 30 seconds of piston slap would happen every cold start. If you did an oil change, it wouldn't make the piston slap worse. So actually the oil change can help you to know, is this like an oil pressure related issue or a piston to cylinder wall clearance related issue, to help clarify that. But yeah, that's part of it. That's part of the reason.
Putting a little bit of oil in the filter before putting it in helps with like that noise.
It does. So now you're thinking like a real mechanic right there. So if you guys understand stuff, you can prime the filter. It's not a bad idea. It's actually it's better, but it's hard to do on the cartridge filter. On the filters that are a spin on that come up like this, not mine right here. See how much of a high roller I am. I got the Toyota OEM, but we'll use my AC Delco OEM. If it goes up like this, it'd be great to put some oil in here. Put some oil right in there, and then it's gonna have a little bit less time as a dry start. How much of a difference that really makes? That's hard to say. I do think it's gonna make some difference. I just can't tell you really exactly how much difference. So, but when I worked on the railroad, we would do work on those big engines, and one of those engines can be $250,000 for the engine, just the engine alone. The whole locomotive is $3 million. So when we're working on those engines and we were doing some of the preventative maintenance, what they would have us do is they have a big lube filter. So the filter would be, it could be a gallon. Like this is tiny. It'd be a huge filter. The standard protocol per the service manual and the procedures was to actually fill that one up with oil. It made it tough though, because it was heavy and you had to, get it on. So I think it's a better quality job. I do, but in the dealer, I don't think it's going to be commonly done. So facts being facts, yeah, I think it's better. How much better? Hard to say. If it's going to slow you down and you're going to make a mess, we're probably not going to do that. Okay, but I like the good questions. Any more before we move on? Okay, here we go. That's some of the reasons that people will buy some of that Lucas oil treatment stuff, because they'll have a little display where like if you put Lucas oil in it and you turn the gears, the Lucas oil will cling to the gears better. And so that was one of the sales gimmicks from back in the day. So as we consider, all of this stuff right here is what's called pressure fed. So pressure fed means the oil pump sucks it up and pressurizes it at PSI. Let's say our goal is 40 PSI of oil pressure. And now that might be, at a certain number of RPM or whatever, but let's say 40 is our goal. 40 pounds per square inch of oil pressure should be spraying out of all these little passages. That means it's force fed, basically. That's one aspect of lubrication. That's always how crankshaft main journals, crankshaft rod journals, camshaft mains. We don't really worry about the cam lobes. Those aren't pressure fed, but all those are gonna be pressure fed. If it's got piston cooling jets, those are gonna be pressure fed. The oil galleries are all gonna be pressurized, even though we're not really trying to feed them. We're just using them to transport oil. But, like when we get into, there's a plug on the side of the block or something, and it goes to oil gallery. That sucker is pressurized in there. You take that out, you might be able to actually put an oil pressure gauge. Or if you want to do your 3-pod A-pillar, race car stuff, and one of them's oil pressure, you may have to run a little oil line or an oil pressure sensor that uses a wire. You're just going to punch into one of those oil galleries, and that's going to give you the pressure of the whole lubrication system. The pressure here should be the same as the pressure here, which should be the same as the pressure there, unless you have some sort of restriction in the system in the oil galleries, okay? But it's a little weird to explain how the pressurized occurs. It has all to do with the volume that the pump can pump. So if we have oil in the sump and the pump sucks it up, the oil doesn't build pressure per se. The oil pump just pumps. The oil pump tries to push it out all the oil galleries, and then it's sort of like a sprinkler system. The sprinkler system is more visual for me. So if you had a certain amount of water that this water pump could pump, let's say this water pump is good for up to 10 different sprinklers to spray, right? It can run 10. And that's to maintain 40 PSI. If you want 40 PSI spraying out of those sprinklers, you can run 10 of them. What happens if you run 8? What's your pressure going to do? Higher, lower, same? You tell me.
Can you repeat that question, please?
Okay, if this water pump, we're going to make it about sprinklers for a second. If the water pump is designed to run up to 10 sprinkler heads and you only put 8 sprinkler heads, what do you think the pressure is going to do? Make more pressure, make less pressure, be the same?
Would it increase the pressure?
It would. That's exactly right. So if you have a pump and the pump pumps a certain volume and you only have 8 sprinklers spraying, that's going to make higher pressure because you're not losing as much water spraying out of the sprinkler heads. So it would make the pressure come up. It doesn't mean that it would not be bad. And then to be really clear, like we have a way to regulate the pressure, right? But at its most basic, the pressure would increase because you have less leaks in the pipe, basically. Then what do you think would happen if you were to run 12 sprinkler heads when the max was 10?
Would that decrease?
Bingo. So your oil pressure is dependent on a couple things. It could be the pump, but I want to ignore the pump for a moment. I just want to think about how many sprinklers are in the system per se, right? You can have up to 10, but unfortunately now you have 12. The reason the pressure is going to decrease is because you have extra leaks in the pipe and the pump is pumping maximum, but it still can't really move enough water into your sprinkler pipe to keep that 40. So as soon as you have 12, you might be dropping down to 30. If you put 16, maybe you drop to 20. If you put 20 sprinklers on that pipe, you might be at 10 PSI. That's when your sprinklers are just kind of like, they're just spraying a little bit. You're no longer getting a nice clean supply. It's the same with the lubrication system. So in this supply system, we have to oil this bearing, 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 this bearing. 1, 2, 3, 4, 5, 6, 7, 8. There's 9. Then we also have to lubricate the cam, but we're going to focus mainly on these lower 9 sprinklers, if you will. If we were to have somehow sprung a leak, that would drop your pressure. But a lot of times the leak is internal, and it's not really like a blown gasket or something. Right here, we have a certain amount of clearance, right? So we're sending oil to a bearing, and it should have, let's say, between 1 and 2 thousandths of oil clearance, right? So that means only 1 or 2 thousandths is open. That means it's only going to lose a little bit of oil. If that bearing gets worn out, and now you got a big old gap right there, like you do a plastic gauge measurement and you got 4, 5, 6 thousandths of oil clearance, what do you think that's going to do to the system?
Decrease oil pressure.
Exactly. You could have low oil pressure due to having worn bearings, because that's kind of like, it's not really like adding a sprinkler, but it's like taking the sprinkler off and just having it be a geyser right there. If you have 2 or 3 sprinkler heads off and you have a bunch of water flowing, you're going to go to the other sprinkler heads and they're not going to have much spray because your pressure's dropped too low. So worn bearings, I want to make sure you understand, will cause low oil pressure. Low oil pressure will mean these bearings are not getting enough oil pressure to cushion the blows of the combustion on that rod bearing. So think about the lubrication system a little bit like that. We're going to come back to it though. Okay. And so that's kind of what it does. A dry sump is a little bit different. This is a wet sump right here. The wet sump has oil in it and the oil pump sucks it up through the pickup. Cool. A dry sump is different. A dry sump is not going to have much of a sump. A dry sump a lot of times is going to have like a secondary oil container or like an oil tank. And the oil pump is going to pull directly from that tank. So in the wet sump, which the wet sump is going to be 99% of the cars you ever work on. But if you were in a race car and you had oil in the wet sump and you went around crazy fast turns, see how that oil could slosh up to the side, right? If the oil sloshes up to the side enough, the oil pump could suck up air right there. So if you wanted to have a race car, a real race car, you probably want it to be a dry sump, because there is no oil sloshing around. The oil is held in a tank and the pickup is deep into the tank. And even going around extreme turns and upside down practically, it would keep the oil not only not foamy and aerated, but it'd keep the sump well submerged in the oil no matter what type of turns you did. That's the main difference between wet sump and dry sump. There's not very many cars out there that were dry sump, but I recall when the first C6 Z06 came to the shop at the dealer, and the PDI guy, who was smart, he knew a lot, went to check the oil and he started freaking out, like, this thing doesn't have oil in it. I don't know what to do. And he was a guy who knew a lot, but didn't really know how to follow the service manual well. So he started kind of freaking out. He ended up actually going and getting the foreman, and the foreman was like, I don't know. We've never had one of those before. It was the first one we ever got, which I got stories about that car. I'll tell you. Good memories. I'm not sure I'll say it on video though, but it was a cool one. That was the first 505 horsepower factory, V8 427 dry sump, 6-speed, dark blue, just good times. He checked the oil and there was no oil in the dipstick. He's like, what the heck is this? So he literally started up, drove it in, shut it off, checked the oil, no oil in the dipstick. And the dipstick went into the oil tank. And it was just kind of weird. He went to the foreman looked it up on service info and said, oh, you have to shut the engine off and you have to wait 3 minutes before checking the oil. So they went back down from his office and they went to the car and checked, and it was perfect. So the way you check the oil level on a dry sump is different, because the oil doesn't just fall into the sump. The dry sump, the oil has to slowly return on the oil pipes and all that type of stuff, which will slowly bring the level up in the external oil tank, which a lot of times can have like cooling fins and stuff. I have actually a motorcycle here. I'll show you this. It's not even mine, but you see this yellow thing? This is a DRZ 400. It's actually got a spot in the frame. So there's a little bit of oil in the engine, but it pumps the oil up to the frame. In the frame, it's got an oil tank built in, and it's got a dipstick right up here near the top of the fork. And you have to run it and then wait a certain amount of time and put the dipstick in the frame to check the oil. It's pretty trippy. So that one's like not a full dry sump, but like a little bit more similar to a dry sump. So they're just different. Other than that, the dry sump would need to have a scavenge pump, which pumps it back to the oil tank. So the scavenging pump basically scavenges the oil and gets it back to the tank. It's kind of interesting. Okay, so that's the main thing about those. And we talked about pressure fed again. I think we're probably pretty good just understanding diesel engines have different levels of heat, different level of pressure, just different demands with those compression ignition CI engines. Okay, then there's another type of lubrication. And this one's a splash. Splash lubrication is literally just stuff that gets splashed. Splash lubrication, it's hard to go wrong. Like on this old air-cooled piece of crap, they would have a little dipper, they called it, and it would come around and hit the oil, and it would just sling the oil up here, sling the oil over here. Everything was just kind of getting splashed with oil. Does that sound as reliable, or like, does that sound as precise, or does it sound a little more approximate? It's just kind of approximate. It's like, yeah, it's going to get splashed. By how much? I don't know. What's the pressure? There is none. We just hope it gets splashed. So it's a reliable system, but it has no way to like cushion the blows of a combustion stroke because it's not pressurized through a journal, but it's simple. So if you look at this one, it's literally doesn't have a crank. It doesn't have a oil pump. It doesn't have an oil filter. It doesn't have an oil cooler. It doesn't have anything. It just kind of splashes the oil around. That's like lawnmower style. That's small engine type of stuff. That's old school air-cooled stuff. So we don't do a whole lot of that, but even within our modern engine, there are still things that are lubricated just by splash. So like a lot of times we'll send oil up to the head, and then once it gets to the head, we just let it kind of like splash around and lubricate some stuff. It doesn't necessarily, it's not real precise. Okay. So it could be either, especially on small engine stuff when they talk about horizontal crankshaft with the dipper and things like that. All right, but now here's the more modern system that's really extensively explained. Oil strainer sucks the oil up. It goes into the pump. The pump sends it to the filter, and in this case, this is actually the oil cooler. So we're gonna filter it, then we're gonna send it to the cooler. If the engine is kind of like in warm up, if the engine's still kind of cold, the oil cooler has coolant in it and the coolant gets warm faster. So an oil cooler actually helps the oil get up to operating temperature first too. Does it both ways. But then once it's up to operating temp, let's say the oil cooler is, actually, let me change what I said. This is a coolant fed. This is a liquid cool oil cooler. On the systems that have coolant going through them, it helps the oil warm up. If it was a more basic system, which this one isn't, and it had an air style oil cooler, those don't really help it warm up. So just so you know, this one is a coolant based liquid cooled oil cooler. It gets coolant in there. When you're in warm up, the coolant's kind of warm, but then eventually, let's say your coolant stabilizes at 200. Your oil under hard work and labor and going up hills and stuff, your oil could get hotter. So if your oil was 220 and your coolant was 200, you're actually going to pass heat into the oil cooler to cool it down, right? You could see that. That's how oil cooler works. And then it's going to go up and it's going to go through the crankshaft journals. It's going to go up through this oil gallery, which is going to spray the timing chain, but also tension the timing chain. And then it's going to go up to the VVT actuators and basically send good oil pressure and volume to these OCV valves. So oil timing, camshaft timing, oil control valve, OCV. From now on, I'm going to call it OCV. Going to send it to the OCV valve where it's going to wait. But if the OCV valve gets a duty cycle pulse from the ECM, it's going to take that oil, it's going to send it through the galleries, and it's going to actually start to change your timing through the phaser, through the sprocket. right? So oil is going to do all these things, but in additionally, cylinder head cover oil delivery pipes, guys at the region like to call those the rainbird system. So you'd send it up to the valve cover, and the valve cover would actually run a little sprayer, and it would spray your cams and your rocker arms and spray all your stuff. Which, by the way, there's a little gasket right there, and if you were to forget that gasket, your whole cylinder head is not going to be getting sprayed by the rainbird system, and you're going to have issues with like rocker arms and cam lobes warm and all this type of stuff. You'd be like, the left head is good, but the right head has all these problems. Well, you may want to check those pipes out. You may want to check for that gasket, because back in the day, all this stuff used to be splashed, but on the newer stuff, we're actually spraying the top of it with those pipes. So if you take a valve cover, flip it over, you're like, what the heck are those? That's what that is. Cool. And it goes to all these different points via pressure. And then down here, there's still going to be some splash lube, but on a more modern engine, we've gone much more to pressure. I'll even show you that in a diagram. So if you look, here's your main oil passage. That's like your water main. That's like your main pipe. And that pipe has pressurized oil in it. And then that pressurized oil is going to go 3 different ways right off the bat. It's going to go to the block. It's going to go to the left head. It's going to go to the right head. This is specific for the 3UR, FYI. When it goes to the block, it also goes to the crankshaft journals, the crankshaft pins, which is Toyota's term for connecting rod journal. Crank pin is a connecting rod journal. And that's why it goes to the connecting rods. It goes to the journal, then to the connecting rod, right? And then after that, it drips into the pan. But it also split off from the block, and it goes to the chain tensioner, which tensions the chain and then drips to the pan. Then it's going to go from the oil passage directly actually to the oil jets, which spray the piston. Those are the piston cooling. Sometimes we actually, on the railroad, we call them the P-pipe, because it pees on the cylinder. It pees on the piston. That was called the P-pipe. But goes to the piston cooling jets, and after that, it drips down into the pan. Goes to the left head, and this is going to be the same, so I'll just cover the left. No, the right head's the same. Goes to OCV valves, goes to VVIT controller, which is the sprocket. So in one of my videos, I called it the variable valve timing controller. And somebody's like, hey man, that's a phaser. It's a phaser for GM. It's a phaser for some manufacturers, yes. I'm showing you a Toyota document, and in this case, they call it the controller. Let's call it the sprocket, okay? You guys know the chain drives the sprocket. That sprocket happens to have what Toyota calls a controller and what most manufacturers call a phaser. Okay, so you saw it. And then from there, it drips into the pan. But it also goes to the secondary chain tensioner, which drips into the pan, and that's the one in the head. And then it goes to the intake and the exhaust cam journals, pressurizes those, and then goes into the head. And then to the lash adjusters, you know, those are the lifters. Pressurizes those, pumps them up, takes away the lash, whatever, then drips into the pan. It gets to all these places and drips into the pan. The reason I like this is, let's just say that you were to have an engine that failed, and the manufacturer, you know, Toyota says, hey, tear it down. We need to know what the failure point is, because you're the big bad MDT. You're my hero. And you tear it down, and you find like the VVT system was messed up. The intake cam journals, the exhaust cam journals are messed up. You could tell the chain tensioner was kind of depressed, and you could tell the lash adjusters are messed up. Do you really think it has 1, 2, 3, 4, 5, 6 problems individually? What do you think the cause of those 6 things having issues are? There's got to be a common theme, right? Think back to electrical. If all your taillights are working, are you back there checking 6 taillight bulbs? You better not. I'm gonna slap you around. You know, the common theme would be this left head, this cylinder head left bank, right? For some reason, oil must not be getting from the main oil passage to the left bank cylinder. That would probably be actually blocking the head gasket, or the head gasket put backwards. Don't know anybody who's done that and blocked off an oil passage. So, right, this is just to give you a visual. This is how it flows. If you were to look at these as light bulbs, and 6 of these light bulbs were to be out, you know, you don't have 6 bulbs blown, although in today's time you might. He'd be like, no, let me go to the main junction, or let me go to the main wire, the fuse. It's kind of like the same concept. Cool. That should basically give you a good understanding of this. Now, let's go to the side that's a little more complicated. But first, I need to put this in a perspective for you, like as like a parable. I had a customer come in at the Pontiac dealer with an engine that was seized up. It was locked up solid. So it came in as a no crank, no start. I go to turn the crankshaft's locked up. Tell him, mate, let's look into it a little bit. I go to pull the dipstick. You know how much oil's in there? Zipperoonie, nothing. No oil in the dipstick. I ended up having to put like 5 quarts in it to get it full, and it held 5 quarts. So it had no oil in it. Okay. And then I noticed it had a recent oil change. So I said, hey, hate to be the bearer of bad news, but you may want to call this customer because there was no oil in this and he just had an oil change. And so you told him it's under warranty because it's only got 25,000 miles on it. But I'm just letting you know, I don't think anybody put oil in this engine. Called the customer. Customer said, no, that can't be. He didn't do it at a shop though. I think he did it himself, or he had a friend do it or something. Okay, so right off the bat, doing oil changes is not a real good business plan, because you're putting at risk something that could be very expensive. And the problem is you're not really making enough money. So if you're gonna put yourself at risk to mess somebody's engine up, you got to be really profitable, right? So he had a homie do it. Homie did the oil change. Somehow oil didn't get put back in it. Now the engine's locked up. That's not warranty, right? Warranties for manufacturer defects. If there was oil in there and it locked up and we found that the oil pump failed or something, it's covered. But if the homie forgot to put oil in there, that's a tough phone call to make. So they made the call and the guy's like, no, it just can't be. There's just no way. And then he got off the phone, he talked to his buddy, and then he called back like later that day, and he was talking with the service manager. And my service manager's cool dude, never fixed cars, doesn't really know that much. But cool guy, I could work with that, because he didn't know he would come and ask. And so he was kind of playing middleman. This customer said, I think I figured it out. My car must have a bad oil pressure relief valve, because I put oil in it, and if that oil pressure relief valve failed, it would spit out all the oil. If that pressure relief valve stuck, it would think there's too much pressure and it would spit it all out. Now, it sounded good, apparently good enough to the service manager to be like, oh, that could be, maybe it is under warranty. Yeah, we just got to tell GM that the oil pressure relief valve was bad, and that's why it spit the oil out, and that's why it locked the engine up. Listen, that would have been what we call a debit or a back flag. They would have submitted that claim for a warranty engine, and then some DSPM or a DSPM would have seen it and been like, I don't know, this doesn't sound right. Get a hold of the FTS or, someone higher up who used to be a tech, by the way. Anybody who wasn't a tech isn't really going to have the juice to tell when a tech's lying or not, right? So they would have eventually got it up to maybe one of those guys we met at the region. And then they would have said, hey, this is the story. And that they immediately been like, nope, back flag that one, because look, if your oil pressure relief valve fails, this is the relief valve. If it fails and it becomes overpressurized, it will open and it will dump oil. But where's it dump the oil? Can you tell? It doesn't dump it externally. That thing failing would just mean it doesn't have any oil pressure. It wouldn't spit the oil out. Oil pressure relief valves don't ever like spit it on the ground and then your oil's just disappeared. That's just not the case. So I actually had to pull something like this up from service information to show the service manager, because this guy was acting like, he's probably going to try to sue if we say it's not covered. So you're in a tough spot as the dealership. You got the customer, you want to kind of give them their way so that they don't try to make a big problem. But if you lie and the manufacturer catches you, they're going to not pay the claim, or they're going to take the money back after they've paid the claim, right? So you ultimately, the thing I would recommend to everybody is just tell the truth. It's so easy. Nobody can pin me down and put me on the spot about lying, because I don't lie. Not today, not never. So it's just, if it's like pretty clear that this oil pressure relief valve wouldn't have spit the oil out of the car. I'm not going to say that it did, because it didn't. You know it didn't. There's no oil externally. I even told them, your engine's clean. All your oil didn't just mysteriously leak out. There's no sign of any leak. There's no nothing. And you weren't like a little low. You were like 5 quarts low. And that's when he came up with the oil pressure relief valve would have spit it all out. And that's why there was no sign of a leak. But it was like, no, you're just wrong. I'm sorry. If the dealer wants to give the customer a good deal and split the parts and labor, if the dealer wants to just give it to the customer to save their reputation, which they don't, because it was going to be like $7,000, right? Whatever. But for me to try to lie to the manufacturer, nah, just not going to do it. Because you already know I would have gotten caught and busted. Okay. So to help you understand, the reason I brought that up is the oil pump sucks the oil up through that pickup tube and whatever. And then it's going to basically send it through the oil cooler and oil filter, if it has an oil cooler, which is only equipped in the tow package on this model, right? Boom, first. Then, if let's just say your oil pressure is too high, which is pretty rare, but let's say you were running the 1540, even though you weren't supposed to, and it was really cold outside in Alaska, that oil would be so thick, it might actually make excessive oil pressure. So what they do in this relief valve, they're going to put a spring in there. And actually they do show it. This is the oil pressure relief valve right here. There's a spring right here, and it's actually threaded in. And if the oil pressure exceeds the tension on that spring, let's say that spring is an 80 PSI spring. If your oil pressure exceeds 80 PSI, it'll actually push that spring down and start dumping oil pressure back to the pan. That's how it works. That's why you can never have excessive oil pressure, because the oil pressure relief valve relieves it, but it relieves it internally. Kind of makes sense? Then there's one more thing that you should know. What happens if your oil filter clogs up? It's not well shown here. If your oil filter clogs up, there's almost always a method for the oil filter to bypass. Bypass means if your oil filter gets clogged and the oil pressure gets too high, the oil just goes around the filter. You generally speaking, in an ASE terms, you will not lose oil pressure due to a clogged filter. I talked to somebody who's a foreman at the dealer, and they said they had one, what they thought it was a filter. They put a new filter on it, fixed it, but it's not supposed to. So I take that with a grain of salt that it might have been something a little bit different, because anytime an oil filter clogs up, the oil should just bypass, which means the oil is unfiltered, but not causing low oil pressure. Okay, that's what you need to know. Cool. Now we go to this. Here's your timing cover, and your oil pump is built to the inside of your timing cover on a lot of the Toyota models. On a lot of all manufacturers do this way now. The reason why, because here's your crankshaft, and that's where we want it to be driven by anyway. So you put flat spots on the crankshaft, you send it through the pump, and you have that oil pump rotor, if it's this design, literally driven by the crankshaft flats right there. That's why I want you guys to be careful and not mark this up with that big old pipe wrench, because if we score that up too much, it won't slide into the oil pump gears well. That's also when you go to do a timing cover, why you have some struggle around the crankshaft right there. You're trying to get it on. It's because you're trying to get the gear in the right spot to slide onto the flats that are on the crankshaft. It could be a little tricky, right? That's its location. Here you can see it gets sucked up right here, goes in, goes to oil filter, and then goes out to the main oil gallery to all the places it needs to go. That's what it looks like as well. There's your relief valve. There's your drive gear. This whole entire assembly is the pump. If you needed to take one apart, you have to pull all those Phillips screws out. And actually, there's some images of what that looks like. So there you go, as you can see. We're going to do some measurement on these, but that's going to be right at the end. So that's going to be part of your lab. And additionally, these are the piston cooling jets. They're bolted into the main oil gallery. This piston cooling jet is spraying this one, and this one is spraying the other cylinder on this V8 particularly. And then there's a check valve so that the oil doesn't just like, when you shut it off, the oil just doesn't all drain out of these and totally dry the system. So there should be a check valve to not maintain pressure, but keep it primed, basically. Keep the oil in the system so it'll make pressure quickly. And we don't really have a whole lot of problems with these, as far as I know. And then here's your oil pan. So you'll notice the oil pan gets really deep right here. Where it's deep, that's called the sump, and that's where the oil pickup tube goes down, and it has the pickup and the filter, the screen. So that's common. Here's your drain plug, you know about those. And then here's a windage tray. So the purpose of a windage tray, the crankshaft is above and the crankshaft's whipping. You don't really want oil being whipped up because then it makes it into that foamy smoothie, okay? If you were to, for some reason, be going around a lot of turns and your oil were to be sloshing all over, it could tend to get foamy and whipped up. So we put what's called a windage tray. Windage tray is supposed to keep the winding action of the crankshaft away from the sump where the oil stays. That would be a little bit of a high performance design. A lot of them have windage trays. Cool, that's kind of typical. And then that's summarizing. Here's a pickup tube that's actually plastic, and it comes right off an oil pump on this Audi that's bolted to the bottom, and that's actually driven by a gear off the crankshaft. So they can vary. Sometimes they look a little bit different, but same idea. If you look in there, there's a screen. You can see a bit of it. Okay, so that's supposed to poke down into the sump and stay submerged, but also do a little bit of rough filtration. Like if it's a big string of FIPG from your timing cover reseal, the sump is going to stop that from getting sucked up into the pump. But other than that, not by much. Now, what we talked about already regarding the sprinklers and how to make oil pressure. Oil pressures are positive displacement. That means the more quickly the oil pump turns, the more it's going to move. So in theory, at least, the higher the pressure will be. The pressure is determined, like it said, bearing clearance and the amount of oil. So if you wanted to increase your oil pressure, you could rev the engine. If you have an oil pressure gauge, a lot of times you revving the engine will change the oil pressure. That's because the pump is pumping more. But it also has to do with how many sprinklers are installed, right? If you have too many sprinklers, your pressure drops. Too many meaning more like leaks in the system, not an oil pan leak, not a valve cover leak. That's like a seep. That's losing oil over time. A leak would be like an oil cooler that's pressurized is literally spraying pressurized oil out. That'll lower it. And that would be pretty apparent. So we don't normally get a low oil pressure concern for a major leak. We just don't. It would come in for a major leak, not for low oil pressure. At the time that it's smoking and catching on fire, they're probably not like, let me check my oil pressure real quick, right? So they're different focus. But also remember what we said about the bearings. The bearings are like sprinklers, and if your sprinkler is supposed to spray a little bit, but the head pops off and now it's a gusher, that's going to drop your pressure too. And that's what they mean. The amount of oil flowing through the system. If you have high flow because you have worn out bearings, that's going to drop your pressure. It's going to do it. Here are the types. We could have roller pumps, crescent pump, geared pump, rotor type. That's these gears. Crescent type. You see this right here? It looks like a crescent moon. That's why that's a crescent type. And then a geared type, or two gears, almost like a supercharger type. So different types. Exactly what type it is doesn't really matter to us. As long as it makes the right oil pressure, we're good. The only reason it would matter to us is if we have a vehicle with low oil pressure and we think it might be due to a worn pump, which, by the way, it might be due to those worn bearings too, remember? But if we think it's due to a worn pump, we have to take these apart. We have to perform precise measurements on each of these parts, and then we can tell what's worn. The way we measure a rotor type, the way we measure a crescent type, the way we measure a geared pump, we measure those differently. But other than that, we don't really care what type of pump it has in it until we have to measure it. Cool. And then the pressure relief valve, I told you, remember that car with 20 something, I think 15 or 20,000 miles that had the locked up engine, it had nothing to do with its oil pressure relief valve. So I wanted to make sure you guys heard that. And I actually had to show him the documentation. They showed him and the guy knocked it. He stopped. He's like, okay, I messed up. I can't really try to blame you or blame the car. I can blame the homie, but the homie's not going to pay for the damage, sadly. Okay, so that's kind of the thing. Now, this talks a little bit about the factors, but what I want to do is summarize that a bit later. Oil pressure, guys know the job of oil pressure. There's two types, but the bypass is much more common. Um, a full flow, that means it filters the full flow of oil. That's less common. That means no matter what, it's filtering all the oil. If the filter gets clogged up, you will have no oil pressure. The bypass, what's it say? It's more common, especially on diesel engines. A bypass, and a diesel, by the way, may use some bypass and some full flow. Sometimes they have two stages. Sometimes they have one filter for full flow that filters everything, and one that'll bypass just in case they're clogged. But it's kind of interesting. The bypass system is going to be more common. A lot of the cars have bypass. If we were to cut that AC Delco filter in, there's a little diaphragm and it does let it actually bypass. If the filter gets bypassed, that just means the oil goes around unfiltered, but we don't drop oil pressure. Oil filters use paper, so if you were to cut it open, it's actually not really that technical in there. There's mostly paper, and the paper could filter down to 30 microns. It should prevent engine wear, but it's critical to change the filter. It could be cartridge, it could be spin-on, stuff you're familiar with. There's your cartridge. This is the procedure you're very familiar with, but this is Toyota specific material. If the filter becomes clogged, a bypass valve operates. Okay, so you read it from Toyota, not from my words. It's just specifying that. The bypass valve can sometimes be in the filter, but on these cartridges, I believe it's more in the housing, typically, in the oil filter case. So now you see, you guys can use the drain plug in the drain pipe. A lot of people don't, but you guys might. You can. It's neater. But you're familiar with these. Now here's your oil filter in action. Oil pump picks it up, sends it through one of the various types of oil pump designs, sends it to. It technically actually sends it to the relief valve, but as long as it doesn't make excessive pressure, the relief valve should be closed. It doesn't really do anything. And then it sends it through the filter, and then it goes into the main oil gallery. If it's a bypass, more common, sucks it up into the pump, sends it to the pressure relief valve, which it shouldn't be relieving pressure because we don't have excessive oil pressure. Then it's going to basically send it to the oil filter. Oh, this is actually a bypass valve in this case. They repurposed it. It sends it to the oil filter, it filters it, and then it should go to the oil gallery. But if this is clogged, if this filter is clogged, it'll actually push this valve open and oil pressure will go directly to the gallery while not having to go through the filter. That's the bypass. Technically, they took this and they just kind of reworked it, right? So you see the labeled relief valve, and then they made this not the relief valve, but probably still is. It's hard to find images with the actual bypass valve. It's a little bit abnormal to show it. You just have to know if the filter becomes clogged, the bypass valve will just let the oil go around. All right, cool. And then you got some spin-ons, some cartridges, etc. Diesel's going to have big old oil filters, etc. There's some different types. This one looks like it's probably going to be more for a diesel style, and these can be pretty expensive, by the way. And then here's another one that's got an interesting story. We had a customer at the Kia dealer come in for a cold start knock. You'd start up and it'd be like, and then after the cold start, it would be fine. So if you were to cold start it and then like shut it off for a second and restart, it wouldn't do it. But if you were to shut it off for like 10 minutes at least, the first startup would go like rod knocky, clattery, timing chain slap, all sorts of noise. And they said, yeah, well, my engine's under warranty, so I want a new engine. And we're kind of like, well, it's kind of weird. The engine, we wouldn't expect to have this issue. So you have to start looking into it. And one of the things that came out in like a service bulletin was aftermarket oil filters should not be on the engine if there's an engine claim. So they said, like, what's the first step? Well, we need to change the oil to make sure that it has the correct oil in it, but also to put a Kia oil filter on your car. And a lot of times the customers would fight and they'd be like, I'm not going to do that or whatever. But remember, when they drop it off, they have to sign for diagnostic time. So it's like, well, you already signed for an hour worth of diagnostic time. So we would just do the oil change as part of the diagnosis. And I specifically remember one. Change the oil, put the Kia filter on there, started it, no clatter. Shut it off for 10 minutes, started it, no clatter. Went back to the service advisor and said, hey, it's fixed. What'd you do? Literally put the Kia oil filter on there. And he's like, oh, we thought it was warranty. We thought it was an engine. We thought it was whatever. The aftermarket filter didn't have what's called the anti-drain back valve. So when you shut the engine off, this little valve a lot of times will push up and prevent the oil from all draining down through that filter housing, like down here. This one that we showed way back here, way back. So far back, further back than I remember. Right here. If this was the drain back, all your oil will drain out of all your galleries and all through the filter and go all through the sump. So the factory filter actually had an anti-drain back, and this aftermarket filter didn't have one. So when we put the Kia oil filter on, it was fixed. It was done, and the customer was just shocked. I think they probably thought we were lying, but we didn't. That's the way it was. So that's the purpose of the drain back valve. So that's just, now you see why I have the AC Delco filters. I have the Toyota filters. I've just seen cars that lose oil pressure when parked due to the aftermarket filter. Okay, and so this has got some more evidence. You could have lower the oil pressure. That would be on the full flow systems, which is possible. It could explode. I've seen them ballooned. If you have a oil pressure relief valve that doesn't open, it could actually build excessive oil pressure and swell the filter up, balloon the oil filter. That's actually been an ASE type question in the past. A ballooned oil filter would be a sticking oil pressure relief valve. Okay, make a note. And so just make sure you got the right one. Now, another thing this talks about is like spurt holes. So sometimes we pressurize oil to the bearing, and then there might actually be another passage in the rod where the bearing excess pressure should like squirt out of this little hole, and that should, let's say, lubricate the bearing, but also sometimes like we'll even try to lubricate the wrist pin, all sorts of stuff. So a little more details when we're doing the engine overhaul. That's why I spent so much time showing you how I clean the parts. Just brake cleaning it and shipping it doesn't tell me that I have no debris in this spurt hole or these passages. Right? So it's kind of like cleaning is important when it's a rebuild, critical. Now this is an oil cooler. That's another coolant one. So it's oil to water. That means it's getting coolant right here, but they have air ones too. They have all sorts of different coolers. I just put in air to oil cooler on my truck to keep my oil cooler, but not with coolant. It literally is down beneath the bumper, so it's catching airflow. So it could be oil to water, which is coolant, or oil to air, which means you need to have it behind the grill or somewhere where it's getting air. Makes sense? If you really wanted to mount it remotely, you could use one of these, a remote mounted fan. So if you wanted to mount it like up in the frame where it's way out of the way, you could, but you got to get airflow. So you could do that with a fan, right? Oil coolers are interesting. It's the same as actually a transmission cooler, except you're cooling the engine oil rather than the transmission. So, which is next semester, later this semester, but the next subject is transmissions. Oil analysis, that's what we were kind of talking about. A lab could actually evaluate whether that oil's better, whether that oil's protecting it better, whether your engine has bearing material. An oil lab, that's what they do. A technician pulling the dipstick out, sniffing the oil, doesn't tell you much. It tells you if it smells good or bad. It tells you if it smells like gas. It tells you if your sense of smell is still working. It doesn't tell you anything at all about the quality of that oil, just so we're very clear. Cool. And so we can send those out. Very good. Now, oil pressure reminders and warnings. What do you want to call this one here? I call it something. I call that the genie lamp. So when the customer sees the genie lamp come on, they're like, oh, I get 3 wishes? Well, your first wish better be to get a new engine, because that genie lamp is really bad. That doesn't mean change your oil. That means your oil pressure is low. How low? Too low. How low is too low? I don't know. Depends. They calibrate this to come on at a certain pressure. But that oil pressure, that means like stop the car. Pull over and shut the engine off now, right now. You run it with no oil pressure like that for just minutes, it's done. Never going to bring it back. Okay, this is the same, except you know it's at 0 PSI. This one is low, but we don't know how low. And then this is different. Actually, check oil pressure is the same. I'm sorry. Change engine oil is way different. Reset, those are maintenance intervals that come on periodically. These are actual low oil pressure readings.
About the low oil pressure reading, I had a car before where I would, if I parked on a hill, like slanted downwards,
Yes.
I would get that oil pressure or that oil light, the red one.
Okay. Yeah, I love that. That's a great example. What are your thoughts? Anybody's thoughts, I guess I should say. On a hill, why would it have low oil pressure when on a hill?
Would a majority of it be leaning to one side and the other?
True, but when they design the sump, they make it deep enough where you should be able to park on a hill and not have it suck up air. The air, I'm probably giving away the answer a little bit, but I'm going to feed you it piece by piece. The fact that the oil pressure light is on means the oil pressure is low. That could be caused by a number of things. But the fact that it's on a hill, I'm already thinking it's air being sucked up by the sump. How would the air suck it up how would the oil pump suck up air from the sump in general? How would it suck up air from down there? There shouldn't be air down there.
If the oil was already low, it could make sense if it's all leaning to one side, it's sucking air up from a different side.
Exactly. I bet you 99% that car had low oil level. The hill gives it away. I'll reword it in a way that you may see these types of concepts on the ASE. If it's on a hill and the low oil pressure light's on, that oil is low. If you're going down the road and you go around a hard turn and the oil pressure light flickers for a second, that oil is low. If you are driving and you hit the brakes really hard and the red oil light comes on, that oil is low, right? They're trying to get it. Do you understand? The oil's moving to one side and the oil pump sucking up air. That's the only thing that's going to cause those. You guys recall there was a concept on the A5 typically about the red brake light comes on around turns or something. They can word it 10 ways. The concept's the same. If your brake fluid level's a little low, it might be okay stop, but if you do hard braking or you do a turn, your brake fluid may go down, sloshing a little bit, and now all of a sudden your red brake light's on. It's just low level.
How about on like startup? Like you start it up, it's on for a couple seconds and then it goes away.
That's an interesting one. I would relate that more to that drain back type of thing. So like when you first start an engine, if all the oil drained out through that oil filter, it's going to take a while to build up the prime again. If it was after an oil change, that's normal. But if it's on every cold start, somehow that thing is losing oil prime. So the oil is like draining out of all the oil galleries. When you start it up, it takes a while to fill all those oil galleries again. We just shouldn't have to be going through that on every startup unless there's a problem with the drain back. Those are my thoughts. Cool. So these are all really bad. But the next thing we're going to talk about, well, there's a little bit more, but we're going to come back to these. Why would it have low oil pressure? Because low oil pressure means a big problem, but like, what are we selling the customer, right? So we're going to come back to that, okay? A lot of the time, the reason that oil light comes on is there's a sending unit, sending unit is like an old school sensor. A sensor is an input to the ECM. A sending unit was an input directly to the gauge, right? So like this one could be paired with a sending unit. The sending unit comes up with a voltage, and that voltage is basically transferred into a needle movement. Makes sense? That's what a sending unit is, so everybody knows. That's old school. Now what's more likely, it'll have a full-blown sensor, and the sensor will send a voltage to the ECM, and the ECM will interpret it, and then the ECM will command this little stepper motor via duty cycle to point to a number. Okay, that's more modern. You could technically run into either one. Additionally, it's really common to have this message. Oil life monitoring, it's not checking oil pressure, it's not looking at oil temperature, it's not saying your oil level's low. So I had a friend and he had a Silverado, and I don't remember if it was me, but I was at least a part of it, so I'm just gonna say it's me for simplification. I did the oil change, which I feel bad because I don't think I did this, but I did the oil change, gave it back to him, and then his change engine oil soon light came on. He's like, man, you forgot to change my oil. I'm like, no, I changed the oil. I just forgot to reset the light. Nope. The system knows that oil's dirty. The system knows. That system is checking the pressures and stuff. It knows that oil's dirty. I'm sure you forgot to change the oil. I'm like, no, dude. I'm telling you, I changed the oil. That light just comes on every 5,000 miles, period. Okay. It's not smart. It just comes on an interval. So mostly that's how the change engine oil soon systems work. So you guys all know. But they do have, and that's what it's saying, but they do have more advanced ones that, so the first advanced one would be, it tracks not only your 5,000 miles, it looks at your mileage, it looks at your idle time, it looks at how many months it's been, it looks at your oil temperature, how long it was hot, you know, it looks at all these things, and it comes up with like an algorithm to make the light come on. And those are actually better than a maintenance reminder, 5,000, 10,000, whatever. Those are better than a sticker. My Hummer has that. The GM was really into those. If it's a GM oil life monitoring system, I would change the oil when the light comes on because it checks all these things way more accurate than just do it at 5,000 or do it at whatever. Makes sense? Because it's looking at your idle time. If it's a 5,000 miles and you leave it idling outside your house for a month, your your oil change light's not even going to come on because you haven't gone any miles. So some of the systems are better than others. It varies. And I haven't seen this, by the way, they do have systems that could actually do conductivity measurement through the sensor. That's going to be like some very exotic high-end stuff. That would be very rare. Okay. That's not what was happening with my friend Silverado. My friend Silverado just comes on like based on time and miles and stuff. It doesn't measure the oil at all, for sure. And then you guys all know about resets. You're the experts of resets, so you should be good about, you know, the resets can vary. Trip B, odometer, plus press the gas pedal 3 times. Go through the information system and find the oil life and press and hold. You know, sometimes it's through the radio. It can be all over the place, but there's a reset. On some cars, you actually have to do it with a scan tool. It's kind of frustrating. Now, when we do our oil inspection, we're looking at the quality of oil. So if it's brown, it looks like a mocha coca frappuccino frappe thing, whatever. That is being mixed with coolant or water. So we would suggest maybe, hey, check out the head gasket, cracked head, cracked block. If it's thick and sludgy, that means it's overheated or it's been a long time. So if it's overheated, we got to find out, why is the engine hot? If it's been a long time, we got to slap the customer around and say, hey, did you forget to change your oil? Because there was an instructor at the school the other day, and he was saying, oh, yeah, last time I changed my oil, I need to change the oil. I need to change the oil. Yeah. Use the shop while I was there on Saturday doing some hybrid stuff, hybrid training. And he pulls in and he is like, oh my gosh, I can't believe it. My oil filter is dated 2022. I can't believe that much time has gone by. I haven't changed the oil in 2 years. And I was thinking like, uh-oh, don't want to do that, right? So that's when you coach the customer. Hey, I looked in your oil cap. I pulled your valve cover, whatever. Your oil's sludgy. You're not changing your oil often enough. Even if you're running that Mobile One and it says guaranteed for 15,000 miles, if you pull that valve cover off and it's sludgy, I would tell them change it more often. The sludgy is a problem. Dirty is not necessarily a problem. Sludgy and thick is a big problem. It says it right there. Now, gritty or visible material, okay, then there's something wearing. We might have a bearing, we might have a cam, we might have something, but if there's excess metal, not fine glitter sometimes, you know, just a little bit of metal is normal, but if you can feel it, it's excessive. If you can see a lot of metallic, it's excessive. What it is, I don't freaking know. That's the thing. Sometimes we got to tear them down. But you can at least give them a warning. Hey, there's something failing here. We don't know what it is, but we know something. Do you want to tear it down? Yes or no? And then thinned out and smelling like gas. Remember the technician? It's going to be like, oh, that smells like gas. That's going to be probably because there's excessive gas in the fuel, in the oil. Why is there excessive gas? that could vary. So if we go back in the day where it was actually pretty common, carbureted cars would be pretty typical to have fuel going into the, let's say they were to overfuel, they were to be like, run a little bit rough. Fuel would go into the cylinder, it'd sit on the piston, it'd go around the rings, it would end up in the crankcase. Like if you had an event where your car wouldn't start and it was flooded and you kept cranking it and trying to goof around, you could actually get gas in the oil. That would be carbureted problems. If you were to have it in a present day vehicle, why is there excess fuel in there would be a little hard to say, because like, let's say maybe you had a misfire. Maybe you had a misfire and it was a little bit older and it continued to spray the fuel. You'd have raw fuel being sprayed into your cylinder and it wouldn't get burnt, and then it would get down the cylinder walls. So that could be it. But the thing is now, if there's a misfire, they turn off the injector. So this old school technician stuff, you'd see old school guys, they'll tell you, they'll do the dipstick. Does it smell like gas? Like, you're not going to see a lot of people sniffing dipsticks anymore because we don't really get fuel in the oil anymore. But if it's an oil pressure concern or something weird, you could smell it. Just generally speaking, if a technician comes up to you, especially with their hand behind their back, and they say, "Smell my finger," I probably wouldn't do it. Smell this dipstick? I might do it because it could be legit. I'm just not sure how legit it is, okay? Because it doesn't really happen that much anymore. Now, when we go to diagnose it, you have to really understand what prompted it. If it's sludginess and you talk with the customer and you say, "Hey, how often are you changing your oil?" They may not be really honest, but if they say, "No, I'm changing it every 5,000 miles, I've got receipts and everything," well, then actually there is a chance that if we were to have, let's say, maybe a major problem with the engine getting really hot all the time, it could actually sludge it up early. Or if we were to have, there's even maybe some ways that the PCV system can cause sludging. So it's not to say that sludging is only possible due to lack of maintenance. It's just that one's the most common. Makes sense? And then let's say that we were to have oil leaking seals, right? That's a little bit like lubrication system related, but typically an oil leak is pretty easy to see visually. So we're going to want to be going ahead and checking, maybe degreasing it, cleaning it, diagnosing the seal, replacing the seal. But how much oil is it losing from that seal is a little hard to say. So people get pretty ambitious with selling these timing cover reseals, and you'll see like a slightly wet timing cover with some dirt on it and be like, "Your timing cover is leaking." If a customer may say, "Well, like, how important is that?" You'd have to try to figure out how much oil they're actually losing from the leak. So I'm gonna be really blunt with you. If they can go a full 10,000 mile interval and not be a quart low, I don't know that the leak's a really big deal. If they have a leak that never even leaves a drop of oil on their perfectly clean garage floor at home, I don't know that that's a really big deal. If you can see the oil leaving drops, I'd say it's legit. If it's losing enough oil where it ends up low between intervals, I'd absolutely say that's legit. Because remember, our job is to provide goods and services to the customer. If a car is losing oil quick enough where they're going to run it low and potentially seize the engine up, it would be us saving the day to say, "Hey, you need to fix this," because if you don't, you're probably going to ruin your engine and that's going to be more expensive. So I want to save you money by fixing your oil leak. That's a legit sale. If you're like, "Hey, the work is slow, let me look really hard for a seeping, barely leaking, wet timing cover," I don't know. Have to answer for that. You know what I'm saying? So considering all those things, also we could have a low oil pressure warning light. We got the Genie light on, we got to troubleshoot that. We might have a noise, we got to troubleshoot that. So that's all lubrication systems related troubleshooting. We can go into a little bit more in detail. Low oil pressure could result in ticking, tapping, clattering, rod knock, etc. That could also be caused though by low oil viscosity, so like fuel, or let's say they ran a 0W20 in a car that was supposed to have a 10W30 or something. That could cause ticking. That can do that. Low oil can cause it too, by the way. But low oil would cause low oil pressure, so it's still low oil pressure. Now, burning oil, that's oil consumption. That's different. Oil consumption is where you don't have a leak necessarily, but it's consuming oil. So if you want to do the consumption test, you're going to top the oil off, seal the cap, seal the dipstick, seal everything. Tell them to drive the car. They're going to drive the car for a certain number of miles. Maybe let's tell them 1,000, and it's going to come back, and you're going to pull the dipstick, which is going to break the seal that you made, and see how much oil it's lost. If you're losing oil, first thing you got to check is leaks. But if there's no leaks and you do the consumption test and it's still losing oil, you know that could be being consumed, burnt by the engine. It could be maybe left on the cylinder walls and burned through the piston. Maybe you have worn piston rings. Could actually have a problem with the PCV system where the oil that's supposed to be, captured by the PCV system is somehow ended up in the intake. If it's a turbocharged car, you may actually have bad seals in the turbo on the center rotating assembly, and the oil is actually getting into the intake stream and it's consuming the oil. So there's so many different ways that the oil could be consumed. We'd actually probably have to do more diagnosis and possibly even a teardown.
What would cause the oil to go through the PCV into the intake?
It's a little hard to say. So it depends on the system, and we're going to cover PCV more in depth. So I'm going to give you a light answer, not a super detailed answer. If it's, let's say, a baffle style, it pulls the oil, it pulls the air, which is going to have some trapped oil, into the baffle style, and it should kind of like separate it. But some of them were designed poorly where they couldn't really hold that much oil. And once it's full, the oil stays in the airstream and it starts consuming it. So we saw like on a Saab, for example, whereas the baffle style, and it was not well designed. And they came out with a TSB saying, hey, we screwed up. You got to put this bigger style baffle on there. So it might just be a poor design, or it could even be, maybe somebody's done modifications that could cause it, or maybe even you have a PCV valve that's stuck totally wide open and it's pulling a lot. That would give a couple other problems too. So it's not real common, but it's possible. And so pause that for PCV a little bit later. Okay, cool. Now, and the burning oil could also be from worn valve stem to valve guide, right? Worn valve stem to valve guide. The clearance excessive, that's going to have the oil running by the valve stem seal into the valve, dripping onto the cylinder. That would consume it. But you'd most likely get the smoking on first starts in the morning, so that's a little bit of a clue. And then low oil pressure can also be caused by foaming oil. So I'm going to pause that for 1 second. We're going to come back to that. When we're going to diagnose, we could be using oil pressure gauge, a DMM or DVOM, dye, oil pressure sending unit sockets, which are special. I have some here. This is kind of old school, but an oil pressure sending unit may not actually have a regular hex. It might need a special socket. So more lately, they've been more normal, but in some of the older school stuff, they had special sockets. You needed to get them out. Sometimes we use a variable resistor. This is a little bit dated. Typically, what we would use now, we could actually use the scan tool, and we could do scan tool testing. That would be my number one tool for this. But if you think it's got low oil pressure, and it may, the most concrete thing to do is to measure the oil pressure. We're going to be doing that this week. So you're going to literally go to where the oil pressure sensor is, take the sensor out, thread an adapter, hook the adapter up to hose, put on a gauge. Then you're going to start it, and you're going to follow TIS. TIS may say warm it up, measure it at 800 RPMs, measure it at 1,000 RPMs, measure it cold, measure it warm, measure it, whatever it says, compare it to spec. But generally, the spec is just going to give you the minimum. It's not going to say, oh, it should be between 8 and 40. It's just going to say the minimum is 8. If you're above 8, you're good. See, it's kind of funny. They generally give the minimum oil pressure, and it's low too. It's lower than you'd think. That oil light won't come on until the oil pressure is very low, not kind of low. So if you were to jump on the Camaro forum everybody and their brother is obsessed with oil pump failure. And there have been some legit oil pump failures, it's true. But people are watching that oil pressure gauge and they're saying, well, mine's 40, but mine's 30. It's like, you guys, 30's fine. 30's good. 30 might just be because you're in Florida and it's hotter, and 40 might just be because you're in the north and it's colder. It doesn't necessarily mean like if you're a little bit higher, a little bit lower, that you have a major problem. All the engines are going to be a little different based on the bearing clearances, which we measured with plastic gauge, remember? So they're going to vary. You just want to check it and compare it to spec. Okay, if it's above spec, we're good. We don't attempt to repair. So if you had the red oil light on and you check the oil pressure and the oil pressure is good, how the heck is the red oil light on? Well, that would be more of electrical diagnosis. But if you check the oil pressure and the oil pressure is in fact low, you're not diagnosing the electrical reasons why the light is on when it shouldn't be on. You're diagnosing why does it have low oil pressure, right? So this is my first step. If it's got a low oil pressure warning, I'm going to actually check the oil pressure because I want to eliminate as many possibilities as possible in one step. I put this on there. I tell you right away, is it electrical or is it actually low oil pressure? Make sense? Now let's just say it's low oil pressure. Here are the causes. Low oil level. I would probably check that first. That's keep it simple, stupid, do the basics, check the oil level. You could even smell it. Smells like gas, you got a problem. Okay, if it smells like sugar, you made enemies and somebody filled your crankcase with sugar. It's happened, right? Low oil level, that's common. High oil level, what? Can someone explain this to me, please? High oil level, wouldn't high oil level cause high oil pressure? Is this a mistake? Anybody? Someone help? Will you help me? It's not a mistake. If you were to overfill the crankcase, think of what happens. You overfill it, the sump is still sucked in there. The reason the system makes pressure is it pulls a volume of oil. You filling it up too much doesn't make it pump more oil. You filling it up too much actually gets closer to the crankshaft, and the crankshaft is spinning. And if the oil level is high and the crankshaft is spinning, what's going to happen to your oil? What's it going to look like? It's getting whipped up by the crankshaft. You remember this? We talked about.
Nice and foamy looking.
Foamy. And if it's foamy, it's aerated. So foamy and aerated, interchangeable. Foam is how it looks to you. The technical would be it's aerated. It's got air mixed into it. If there's air mixed into it, you guys remember Pascal's law a little bit with brakes, right? If you have aerated fluid, your pedal's spongy, your brake fluid pressure is low. Your oil's the same. If it sucks up air into the pump, it's trying to pump up a liquid, but instead it's got air in there and the air is compressible. It lowers your oil pressure. So low oil level, oil lights on. High oil level, oil lights on. Period. We're not going to even have any discussion. If the oil temperature is really high, like it's overheating, the oil will get thinner and thinner and thinner. So I want to point something out. We talked about multi-viscosity oil, and the multi-viscosity oil showed 0 winter is actually going to be thinner when cold, and then as it warms up, it's going to be a 20, right? No, I'm sorry. Kind of. At 0 W, it's going to function like a 0 weight oil would at 0 degrees. And at 20, it's going to function like a 20 weight oil at 212 degrees. It's still going to be thinner when it gets warmer. It's just not going to thin out as fast. So like if you were to have 0 weight oil, boom, you know what it's like at 0, and you know what it's like at 212. If you were to do the test at 0, it's going to be like, oh, this is a 0 weight oil. But if you were to redo the test at 212, it'd be like, oh, this is a 20 oil. That's what 0W20 means. It does not mean it gets thicker as it gets warmer. No. It just means it passes with the numbers of a 0W when cold and a 20W when warm, even though it's thinner when it's a 20W. Okay, so hot oil is thinner, that could cause low oil pressure. You could also have worn engine bearings, excessive oil clearance. We're gonna come back to that. A worn oil pump, missing oil plugs, which that'd be massive leak. Okay, they wouldn't be like, hey, I have low oil pressure. They'd be like, all my oil is on my floor. It's all over the place, and I slipped, and I hurt my hip, or whatever. Missing oil plugs. That's what I was saying. Sticking pressure relief valve. You know that is possible, but sticking which way? I want you to know, because I want to point something else out. Sticking oil pressure relief valve causes low oil pressure or high oil pressure. What do you think?
Hi.
It says low right here. So is it low or high?
The chart says both.
Oh, indeed it does. Is it wrong? It's a mistake. It's not a mistake.
No.
Here's why. I'll tell you. If your oil pressure relief valve is stuck open, it's dumping oil into the pan, you're going to drop pressure. Cool. It's stuck open. But if it were stuck closed, it wouldn't vent your excess oil pressure, which means your oil pressure would be too high. So this one, you could say sticking open pressure relief valve, and this one for high oil pressure, you could say sticking closed pressure relief valve, but they're both sticking. ASE doesn't have to specify. Sticking could be either way. If it says sticking, you can't say, well, they mean sticking open. They didn't say sticking open. You added open. If they say sticking, you don't know. It could be sticking open or sticking closed. Cool. Similar with wrong viscosity, by the way. Wrong viscosity can cause low oil pressure, high oil pressure. Wrong viscosity causing low oil pressure is going to be low viscosity, low numbers. Wrong viscosity causing high oil pressure is going to be high numbers. Like you're running 80, 90 for engine oil. That'd be fun. Okay, and then air leak in the oil pickup tube, like I kind of discussed that, it would suck up air. Plug the oil filter only on the type that doesn't bypass. So this is always a struggle for me. As far as I understood, all the Toyotas bypass. But right here, it says it could be a plugged oil filter. So I'm not sure. I'm going to tell you straight up. If we were to find an engine that we know has no oil bypass, then we could confirm a plugged oil filter could cause it. But I'm not sure. Whole flow or bypass, I don't know. And then, like I said, wrong viscosity, right? So let's go to the high oil pressure for a quick second. The stuck closed would cause it. The too thick of oil would cause it. And the only other thing that would cause it is a restriction in the lubrication system. Remember, that system is supposed to have up to 10 sprinklers, but if for some reason it had no sprinklers, it would actually increase the pressure. It would go up, and that could be excessive. That's pretty much what we got to figure. When you get a low oil pressure concern, you got to know it's all these things. But if you get a low oil light, you need to know, is it the light coming on when it shouldn't, or is it actually low? And then you got to do troubleshooting. Cool. And this shows you, here's the sensor or the sending unit right there. We're going to take that baby out. It's got actually pipe dope or PTFE, like Teflon tape or liquid Teflon on there. Be very careful with these. Sometimes it's a straight thread with an O-ring. Other times it's what's called a pipe thread. I actually brought a little, it's actually a nipple, if you must know. This is a pipe thread right here. If you were to look really carefully, this pipe thread is not straight up and down. It's actually tapered. It starts a little small and it gets a little bigger. With something that's pipe thread, when you go to thread it in, it's going to have Teflon tape or liquid stuff, which sometimes I'll call it pipe dope. I had some, but I actually don't know where it's at right now. So when we go to thread this in, it's going to start easy and it's going to get like kind of hard to go, and you're going to see all these threads left. If you try to thread it till all the threads are buried in there, you will break whatever you're threading it into. We've had students try to hook up this oil pressure gauge and see there's still threads, so they keep cranking on it and had them literally crack a timing cover. All right, so I'm just letting you know, it might be straight thread, in which case it seals on the O-ring, but if it's tapered like this is pipe thread, you're going to Teflon tape and pipe dope and whatever, and then you're going to thread it in and you're just going to torque it to spec, and it may only be 7 foot-pounds. And if you try to go 70 foot-pounds, something's going to break, and it's probably not going to be this. It's going to be the aluminum female cover that's going to go. right? In which case, somebody is going to be in trouble, okay? So that being said, we're literally going to unthread that, and we're going to find the exact adapter. Like this one, see, we're matching these up. This one's tapered and this one's tapered. We're going to need to put some Teflon on here if we want it to not leak. Then we're going to thread it in, torque it to spec, 7 foot-pounds or something. And then we should be able to start it and look at the oil pressure, measure the oil pressure. And then when we're done, record the oil pressure at different temperatures and engine speeds and all that type of stuff, record it, and then button it all up. And now you have your oil pressure. Cool. Now, if you wanted to do oil sensors, probably what I would personally do is see what information you can get on the scan tool, because it's so much quicker. Hook up the scan tool and see how many PSI or how many volts it shows, and you could tell so much. But back in the day, what they do is they would try to put different resistors in to simulate good pressure to see if it would turn the light off. It was kind of old school. You guys had a lot of electro. You should be pretty solid, okay? You might get into the wiring diagrams to see is the sensor getting the voltage it needs. But what I want to do is show you really how that reads, okay? This is just talking about like measuring with the meter. This is a diagram. Let's say that you had the red genie lamp. You had low oil pressure light. The way it works, you're going to turn the ignition switch on, and that's going to give 12 volts to the basically to the warning light. And if the warning light's on, that means what is being supplied on the blue wire? You think? If I send 12 volts to the light, exactly, ground. I heard you start to say it. So if I send 12 volts to the light, anytime the key's on and the light is on, that means it's grounded, right? That means the blue wire is grounded. Why is the blue wire grounded when I do 2 clicks of the key? Key on, engine off. Why?
It makes contact.
True. So in here, when we don't have enough oil pressure, it's grounded. It's grounded because it's threaded into the block or the oil filter housing or whatever, wherever it's at. With 0 oil pressure, I promise you that oil pressure sensor, sending unit, switch, whatever is going to be grounded. It's just the way it is. So when we start the engine, you notice it takes a second and then the genie lamp turns off, right? Anybody think they know why?
It's putting pressure, so it makes contact.
It's close. I want to jump to this page. What it actually does is when there's no oil pressure, this comes down and it makes contact on these contactors. That supplies ground. When the oil pressure is built up, it lifts this diaphragm and it opens the contacts. So if we use it in correct electrical terms, the switch is closed with no oil pressure. The switch is open when it has oil pressure. How much oil pressure? Well, it depends on these springs. Let's just say, for an example, 6 PSI. Those springs make 6 pounds per inch. If we have 7 pounds of oil pressure, it's going to compress the springs a bit and it's going to open up these contacts, at which point it'll send 12 volts, but it'll take away the ground. So what happens to the light? What happened to the light? What happened to the light, man? Light turns off. Yeah, the light turns off. Exactly. But if, let's say, you have low oil pressure and you can't build enough oil pressure because it's airy, because it's low, because it's foamy, because it's sludgy, because it's whatever, all those things you talk about, then you can't build enough oil pressure right here. This thing is going to come down and contact. In Nate's example, the car that was parked on the hill and the light would come on, that's because it was sucking up a bunch of air, not building much pressure. The springs were overcoming the 6 PSI or less of oil pressure and contacting, and then you get the genie light on. And that's why sometimes if your genie light's on and you rev it a little bit and it goes off, you know it's kind of borderline low pressure. And then you're like, ooh, I don't know, I got to really diagnose this one. Whereas if it's on solid and it never goes off, you know, that would be more like, hey, you know, maybe this one's an electrical type of thing, but you still might want to really check the oil pressure. Makes sense. And then let's say like we gave the example, you have a red oil pressure light on, then you go around a turn and it goes off, or the other way, you have it off, but you go around a turn, it comes on. I may not jump to an oil pressure test on there. I may really put a lot of focus into making sure the right oil levels on there, which shouldn't take much. It should be pretty easy. Daniel, go ahead.
Is it possible to open that up?
Generally, no. I actually have one. Oh, you know what? I think I threw it out. No, I haven't. I don't. I have the bag. I changed the oil pressure sensor. I got an Amazon one. It was $10. I put in the guy's car, and then it actually ended up failing after like 2 weeks. And so I had one, and I was gonna return it, under like kind of warranty. And then I just realized like I'm not gonna drive down to the post office for this $10 piece of crap, and I threw it in the trash. So you can't really take them open. You can't really take them apart. But what we can do is we could troubleshoot it. So if we back up right here, if we have ground here, that means that the switch is grounded while it's running, right? You want to test it while it's running. It should not have ground here while it's running, correct? Because if it's running, it should take the ground away. If it has the ground while it's running, then we need to shut it off, and we need to unthread it, and we need to hook up the gauge, and then we need to measure the actual oil pressure. If your oil pressure is good, then you know that sending unit is bad. Makes sense. If your oil pressure is good, but your switch is still providing ground, there's something wrong inside. We're done. We know it's no good. If your oil pressure is bad, you're not worried about the sensor or the switch anymore. You're diagnosing oil pressure. You might have to do teardown. You might have to do whatever. Okay, so it's actually it's really pretty simple. If it was a sensor, and that's what this diagram is, but it's a little tough to see, it might be a little more complicated. But when you guys did diagnosis on pressure sensors and just sensors in general, a lot of times you're seeing if the sensor is a 3-wire, it needs 5 volts in ground, and that third wire is a reference. You just diagnose it as any other 3-wire sensor. Make sure it's got 5 volts, make sure it's got ground. You can actually jump the 5 volts to the signal wire and look at the scan tool and see it spikes up. You could unjump that, jump the ground to the signal wire, see if it pegs low. That's really just telling you about the circuit. If the circuit passes, then you change the sensor. If the circuit fails, then you have to measure, from A to B. Is it in the 5-volt wire? Is it in the ground wire? Is it in the signal wire? So it's the same as any of the 3-wire stuff. Truth be told, though, the A1 is not really focused on that, so I don't really focus on that. Okay, now let's say it's low oil pressure. This is probably the number one thing that I'd be concerned about. Bearings wear, it's what they do. If it's got low miles, I might not jump to this. But if it's got a bunch of miles on it and it's got low oil pressure, I'd be like, I wonder if it's got worn main bearings. To know that, you know what you got to do, right? You're gonna have to tear the crank out of it and do the plastic gauge. If it's got very worn main bearings, you're gonna have a very tiny plastic gauge smear because the main bearings are worn. So maybe it just needs main bearings, or you're gonna do probably a rebuild. Kind of makes sense. That happens at high miles, but it's inevitable. Eventually, those bearings are gonna wear. Eventually, right? Another possibility though is an oil pump. So if you think it's an oil pump, you also have to tear this down too. So you got to get at the oil pump. You got to disassemble the oil pump. This one, for example, is measuring tip clearance. You're putting a feeler gauge between the drive gear, because the drive gear drives the pump, which are these 2 gears. Those 2 gears are the pump and the housing. So the drive gear is driving the driven gear, which is being driven. Make sense? It's kind of weird because the drive gear is actually driven by the crankshaft. Does that make it the driven gear? Well, not really, because we're just talking about in the pump. This gear does the driving. We don't worry where it's being driven from. Make sense? Drive gear, driven gear, tip clearance. You have to know that. Next, we're measuring a lot of times what we'll call side clearance. We're going to lay a straight edge, in this case a square, but we're using the straight edge part of the square, which is legit. And we're going to try to slide a feeler gauge in the face. Sometimes we'll even call it face clearance, by the way, in the face of the gear to the straight edge to see if there's any clearance at the face or like side clearance, right? The drive gear, the driven gear, sometimes even the housing. Cool. And then we're actually worried about the driven gear to the body. They may call it pump body clearance. So, but you see where the feeler gauge is, right? This is the driven gear, and this is the body. We're measuring the clearance between the driven gear and the body. On the ASE, you have to notice where the feeler gauge is. They may say tip clearance on this. That is not tip clearance. The feeler gauge is between the driven gear and the body. Okay, that would be face. That would be tip. That is a different measurement than this measurement. If you pick the wrong answer, you're going to get that question wrong. Okay. That is basically exactly where I want you to be. And if you can understand all those, you're going to be in pretty good shape for this ASE.